Well, hello there. How you doing? I see David is here and DK. How you doing, guys? Welcome to SkyTour LiveStream. And there's Rockstar. Nice to see you guys.
Had to let it.
Yeah.
Hello.
And Laura is here. Yeah. And Marianne Robb. Oh yeah. Yeah. So nice, you guys, to drop in. This image you see on the screen right here is an image of a Messier 33 galaxy. I took this the other night. Right here with the very new telescope. Paul Atreides, how you doing? I love the Dune, by the way. You know, Dune was a great show. That Paul Atreides, that's one of the names. Put, how you doing? Justin, how you doing? And Chango, how you doing? From Mexico. Buenas noches, senor. Great to have you guys here. Hello, Nancy. And I think you guys are going to have some fun tonight. We're actually going to be looking at Betelgeuse a little bit tonight, because Betelgeuse is potentially on the verge. I gotta tell you something interesting too, and I don't know if you've heard this before, but Betelgeuse actually has in its direction, we saw gravity waves that rocked interstellar space, and it's in Betelgeuse direction, and this is a live view of Betelgeuse right now. And so it's interesting to think about the fact that, you know, could that mean something? Well, we don't know, okay? Because when we think about how Betelgeuse actually has, you know, evolved, you know, the astronomy community actually thinks that maybe seeing gravity waves in the direction of this star is actually just a coincidence. Well, you know what? I don't know. I mean, it could be, you know. Hey there, Arizona Skies. And by the way, I just want to let everybody know, tonight we have KGRA's own Carol Carl with us. Hello, Carol.
Hello, Mark, and everybody. Hello, chat. Oh my gosh, great to see all these familiar names, new ones, etc. So
we've got a bunch of people. Yeah,
is exciting.
Yeah, very exciting. You know, we're trying to see where this will go. You know, I don't know. None of us know whether Betelgeuse is going to go supernova soon. Most people think it's going to be in about 100,000 years. But wouldn't that be something if it just went into a bright frenzy just right now in front of your face, right here?
That's what I was just thinking. Wouldn't that be incredible if you got to catch it and be
know.
the person who owned it on the live stream?
I know.
Wow.
Marianne says hi to you, by the way.
Oh, yes. Hello, Marianne. How are you? She's going to be my guest behind the Obsidian Curtain.
Fridays at 7 p.m. on KGRAradio.com.
Fridays. Yep. Fridays at 7, 4 p.m. Pacific.
Awesome.
I'm looking forward to that greatly.
Yeah, that'll be fantastic. I have to just keep Daryl... see the plane go through?
Oh my gosh!
Yeah, Daryl may be joining us. Daryl's feeling better.
Oh, super! Oh, good. I'm glad to hear that.
So we'll hopefully he'll be with us if he can. We're gonna go as long as we can until clouds come in. They're supposed to come in around 9 or 10, but we'll see. Betelgeuse. We used to think Betelgeuse was around 450 light years away, but the latest indications are that it's roughly, and I say roughly because we really don't know, 700 light years away. So the light we're seeing right now in front of your face, right on this screen, is 700 years old. So if you think back how the Earth was 700 years ago, what we were doing, I mean, my gosh, you know, you go back 700 years, take, you know, 2020 and take off 700, and that's the status of the Earth back when this light you're seeing right now left that star. Yes, it's a big universe. Yeah. Right?
Yeah, it staggers the imagination.
It does. In true universal fashion, you know?
Yes. Well said.
Now, here, we'll take a 30-second shot. I'm going to take us to camera sensitivity of 10,000. Why? I don't know. Because we like you, the Mouse Club. Okay?
Yeah, MOUSE, right.
Charles Smar, hey there. How you doing? Okay, here we go. We're gonna
everybody.
take
Hey,
shot.
Justin T. Okay.
Yep. No, go ahead. You're...
Oh, just kind of, and Rockstar, and I know that Rockstar likes that truncated name. Okay, all right. So, all right, Charles, everybody, Nancy, yay.
Yeah, it's so nice to have all these folks come on out. In fact, it's almost like it didn't take any time at all. And all of a sudden, bam, we're up to like 20 people now. So it's like, good. Keep it coming. Enjoy.
Listen, word gets around.
Yeah. Oh, Nancy's saying hi to you too.
Yes, yes. Hey, Nancy W. And Laura Newbert, or Newbert, I guess, is
Laura,
waving.
Yep.
Wave.
Yeah, look at that. So there's Betelgeuse there. Now I'm gonna do something with Betelgeuse. This is just an image one we just took, but I'm gonna do something now. I'm gonna put this in real-time color, and to do that, I'm gonna move us to an editing program right now, and let's do that. So here's Betelgeuse. Let's actually give Betelgeuse and this whole view the proper color, shall we? So to do that, we basically just do a little of this. So this is more or less what the real color is.
More red.
Yeah. Okay.
In the surround, kind of a glow.
Yeah, you see that the red is actually there's a little halo around this. That's an artifact from the camera. It's certainly not stuff around Betelgeuse.
So we are not seeing that reddish pinkish light from Betelgeuse. That is not making that. It is a camera artifact?
Well, it's an artifact created by the bright light of Betelgeuse.
Okay.
As bright as Betelgeuse is, it's now dimmer than other stars that normally it's much brighter than. It used to be the 6th brightest star, and now it's not even 23rd anymore.
Really?
It's got knocked out of the top 10, then it got knocked out of the top 20. And we don't know what's causing it. And then all of a sudden, they see... And actually, the gravity waves they saw from Betelgeuse were actually about a week ago. Not from Betelgeuse, but in that location. Okay? Yeah. So that's something that we had seen, and didn't really know what to make of.
Yeah.
Because astronomers had never seen that before. All right. So now we go back... and this is the live view of Betelgeuse again. And for those who aren't familiar, this is the operations window down here. That's me. Hello. Okay.
Hello.
This is this part up here. This is the telescope control here. This is the main window, and then this is the camera control over here. And then we've added this little extra, which is a little overlay of it's a live it's I should say not live, but it's actually a planetarium that's up to date in terms of what the sky looks like. All right, so this is Orion right here, and we can talk about Orion as a constellation. You can see it here. You see Betelgeuse here. Okay, if I just actually get rid of everything, you see Betelgeuse, Bellatrix, Rigel over here. Okay, and then Saiph over here, and then the 3 belt stars in here, Alnitak, Alnilam, and Mintaka. Now, in terms of mythology, you know that Orion the Hunter, well, here is Orion the Hunter, okay? And next to Orion the Hunter are his faithful dogs. This is Canis Major, and Sirius is the brightest star in the entire sky. It's called the Dog Star. And then we have his little dog over here, Procyon, which is a little hunting dog. And in between the two of them is a unicorn, of all things. Called Monoceros. Mono meaning one, and of course the horn. So, yeah. So that's sort of what we do. We like to show a little of that from time to time.
And it's strange. I'm hearing Amanda's voice. I know she's not here, but you know that.
Oh yeah.
Yeah. Daryl's voice. Daryl's everything is better with Amanda. Well, as you were showing the graphics of the drawings of the animals. Yes, there she was in my head. All right.
Yep, that's exactly right. It's exactly right. And so I do know that we're gonna that we will come back to that from time to time, and it's just a supplement to kind of help us with everything we're seeing. So for instance, if I want to take us down, say now from Betelgeuse, I want to take us down to say Alnitak, okay, this star here. All they have to do is tell us to go there, and you'll watch Betelgeuse zip out of the view, and we will then end up going down to Alnitak. Now the computer's moving the telescope. You can see the telescope here, and it's moving the telescope now, and the telescope is reconnecting with its directions. It's first finding a known star. It's doing what I call high precision pointing. right? It centers a known star, and then it brings the target star into view from that. So we'll see that Alnitak will be in our view here. All right, and
I was going to say that the target star is like a landmark, but in this case, we would be talking about a sky mark.
that is absolutely correctly stated. And as a sky mark, I'm kind of a sky guide in a sense, right?
Right. Yes.
Yeah.
Plus Mark. That sounds good. So,
Yeah.
all right.
Yep.
All right.
Yep. So now we're I'm just waiting to see where the scope is going now.
Uh-huh.
I didn't actually put us on Alnitak. How about that?
Oh.
I'm a dummy. Sorry.
But you're a good dummy.
Can't
A
believe I did
wise
that.
one. All right.
All right.
Okay.
Let me pick
Now
Alnilam, actually, and just get us there first. I don't know why I picked the other thing. So now it's going to take us to a star. The high precision pointing again takes us to another star in the area, and we'll see it's going to Bellatrix, the upper right-hand star, and then it's going to zip on down to Alnilam after it centers this up. It's a process. Hey, Daryl's here.
Yes. Hello, Daryl. Snort, he says.
Yeah, I see that. Yep, and there comes Alnilam. Right there. And we'll wait for this. Wait, where'd it go?
Zipped away.
Yeah, it might not have been Alnilam. It might have been another star. I might have an issue that has to be resolved here.
Does that mean stepping out into the frigid
It
cold?
probably does.
Ah.
Yeah, I don't know why it did that. Well, there you go. See, that's what happens. Welcome to live astronomy.
Right.
Sometimes the technology doesn't do exactly what you expect. I mean, it was working until I started streaming. Then I started to do this. Yeah, really odd. So what are I gonna do? Let's see. Well, we are troubleshooting the scope, so it is
Okay.
tricky. All right, so let me figure out where we are. Scope says we're there, but that's not really true.
Are we there yet?
Yeah, I know, right? All right, I'm going to actually try to go to Bellatrix since it knows how to go there. And I'm going to work from there. Yeah, Daryl's not feeling good.
Oh. We're sending you all kinds of good energy, Daryl.
Absolutely. Oh, look at that. See that?
Yeah, there we go. Okay, hello.
Isn't that? See what's going on there?
Yes, what is that?
Well, we caught a satellite going through.
That was going to be my
We're watching a
guess.
satellite go through right now.
My God.
Isn't that cool?
It is so... Yeah, I was hoping it wasn't a star.
Yeah, no,
because,
that'd be bad. That'd be bad.
Yeah.
Yeah. So if we actually were to bring it up and head a little bit east, here it is. Oh, you can't see it. Sorry.
No, I'm just seeing black.
Yeah, you are, because I have to bring it over more. There it is. Little tiny satellite zipping away. Okay, well, that's pretty cool. Now
Wow.
I'm going to get back.
Just, wow.
Well, who knows? It might have been one of those Starlinks for all we know.
Oh, that would be something.
Oh, I'm sure it would. Okay. All right, so this is Bellatrix, and it seemed to find Bellatrix without any problem. So I'm curious as to why. Oh, you know what? Oh, okay. The high precision guiding may not work because of the darn dome again. The dome could be blocking part of this guiding system. Yeah. That does happen. That's why Bellatrix you can find.
And that's an actual physical blocking that the actual...
Yeah, let me see if we look at this.
Yeah, okay.
It's the guide scope's on the far side of the main scope up here. You can't see it from here. Here's the main body of the scope. Okay? And the guide scope's on the other side, kind of along the line of where my cursor's going. and it might be actually being caught by the edge of the dome,
Yeah,
and thus
okay.
it's unable to find the objects.
Right.
That's why roll off roof.
Yeah, exactly.
Yep, because then there's no dome to
because
contend with.
you can't put the thing. It's not going to have those stock eyeballs like Martians. You can't lift it up and over the. Yeah. Okay. So,
Yeah.
So excellent roll off roof. Yes.
Yeah.
Yes.
And Charles Mars got a question here. Did I catch the new dating for the Australian asteroid crater? The guess now is that it may have ended Snowball Earth 2.2 billion years ago. Yeah, Snowball Earth was a concept that we don't really have solid dates on whether it was Snowball Earth. We just have some kind of incidental evidence. There might have been a period twice in our history where the entire planet was glaciated, the entire planet. And right now, we don't have enough evidence to know whether that was actually true or not. But we definitely have something to think about when we think about Snowball Earth, because it would mean a lot of things. It could have stunted life on the planet, and stunting life on the planet is kind of a problematic thing,
Yeah.
Yeah, there's Betelgeuse right now. Let's see if it's going to stay or go. It should stay right there. Let's see.
Traveling a little.
Oh no, it's moving. Yeah,
Oh,
see
yeah,
that
okay.
it's centering it now, and it should now beep and stop.
Okay.
Okay, and that's the deal. I think it did. I think we're good here. All right, that's good. So Betelgeuse finally learned how to behave. Yeah. Well, you should have seen it earlier. It didn't want to find Betelgeuse. It found every star in Orion except Betelgeuse.
That's hilarious.
Yeah, well, not for me. It was cold, and I was outside trying to get this to work.
How about ironic? Okay.
Yeah.
That's good. Okay.
So the bottom line is, this whole finding issue, the stuff I'm going through. I figure I'm bringing you all along for the ride, even though you see things that may or may not work right. The bottom line is that it's live astronomy. This is what happens.
Exactly. It's a teaching moment.
This is what happens in the real world. I mean, I've been in a large dome with a 20-inch refractor. The floor is around 35 feet across, and the dome was around 40 feet over my head. Well, that varied because the whole floor would move up and down to meet the telescope. The floor was a massive elevator.
Oh my God.
And you'd ride up and down to meet the telescope to actually do what you had to do. And I was working on the parallax program, which is a study of nearby stars. And that parallax program, I'm going to take a 30-second shot here. The parallax program was interesting because we did a lot of good work. We found a lot of really good stars. But you kind of get involved and you forget certain things, like some of the safety concerns. The floor, when it rose up, when you were looking at a star that was lower than the certain altitude, the whole floor had to rise up, like 8 feet, 9 feet.
Wow.
And there was a gate that you had to make sure you closed so that you wouldn't accidentally walk off the floor and drop into the basement, 35 feet below you. And there's a couple times when I almost walked right off because I had forgotten to close the gate. Well, the other thing that happened was I actually raised the telescope at one point, anxious to do the program stars. It was probably 3-4 in the morning, and my shift was midnight to dawn. And I rose up the floor to quickly get to the location. I figured I'll just do this while the telescope's moving. Yeah, that was a mistake, because the telescope was surrounded. Actually, the floor where the telescope came through it, where the telescope came through the floor in the middle, had these wrought iron railings all the way around. So of course you couldn't step and fall in between the telescope and the floor and fall to your death in the basement, which literally was all the way down. Hello, Kimmy. Yes, the gatekeeper.
That's great.
But as I rose the floor up, I heard this gut-wrenching noise. I was like, what, stop. I
Oh.
quickly stopped the elevator, the floor elevator,
Right.
and I turned on the flashlight, because you never turn on a flashlight in the dark because it ruins your night vision. I turned it on to see that part of the telescope was bending the 2-inch wrought iron pipes that were, going around the telescope.
Ouch.
Yeah, that was a big problem. And that dent is still there to this day.
Have you signed it? Is there a plaque?
No, I don't think they wanted me to. I don't think they want to remember what happened, and I don't blame them. It was a awful experience. I just can't believe I did that,
Wow.
Almost as bad as being trapped by a ladder folding around me in the other dome, because I was so intent on guiding a very faint object in the eyepiece that I didn't take my eyes off that eyepiece for an hour and 45 minutes. And in that time, the Earth moved about 20 degrees or so, a little more, and actually almost 35 degrees. And in so doing, it had pinned the ladder I was sitting on to do this guiding against the wall of the dome.
Whoa.
And it slowly started folding it on me, and I didn't notice, until the exposure. I couldn't keep guiding anymore, because no matter how much I tried, it wouldn't move. I was like, something's wrong with the telescope. What was wrong was this big giant ladder that was between the telescope and the dome, preventing it from moving. It finally bent it as far as it could. So I cut the exposure, turned on the lights with the remote, and looked down. To my horror, I see that I'm wrapped up in steel. And I didn't feel any of it because I was wearing a winter coat. It was like 10 degrees in the dome, and I was really cold and just sitting still. So I had to slide out of my coat and go down through this folded ladder and get out the bottom, and then pull my coat down through and then put it back on. Yeah, I didn't live that one down for, I'd say 2 years.
A true Houdini move.
Oh, Houdini move. Are you kidding me?
No, I mean getting out of the jacket.
Yeah, well, yeah.
Oh.
I should have been put in a straitjacket for that. For those just joining us, this is
Thank
Betelgeuse.
your lucky stars. Okay.
And this is Betelgeuse for those just joining us, so you know. And we took a photo of it just a few minutes ago, and that photo looks like this. Here it is. And when you edit that photo to put it in proper color, it looks like this. Okay, so that's what we're seeing there. So Betelgeuse is this brilliant red supergiant. Interesting thing about supergiants, they get their brightness not necessarily from their temperature. That is related to where the brightness comes from, but the radius of the star makes up a big difference too. If you talk about the intrinsic brightness, the brightness we see of Betelgeuse right here, okay, this brightness is less than what we're used to seeing for Betelgeuse, as many of you know. However, this star is also, being a supergiant, it's also a variable. It will shrink in size, it will grow in size. And when Betelgeuse shrinks, it gets a little bit dimmer because its radius is getting smaller. And then when it grows again, it gets its brightness back. Okay, so there are times when regular old Betelgeuse that we used to know would be a little less bright than Rigel down at the lower right of Orion, which is this star down here. Okay, it would be a little less bright than Rigel, then sometimes a little bit brighter than Rigel. All right, but now Betelgeuse is a lot less bright than Rigel, and we don't know why. And that's the thing that's making this crazy. However, we do know what makes stars bright. And the intrinsic brightness, as we call it, is also known as the luminosity. And the luminosity of Betelgeuse is related to its radius, as I mentioned, and it's also related to the temperature. Now, as Betelgeuse raises and gets bigger, as Betelgeuse gets bigger, okay, it will actually be brighter because the radius is increasing, and the luminosity depends on the square of the radius. So radius squared. Okay, so a small change in radius, if you double the radius, it goes up 4 times as bright. Okay, however, the temperature associated with luminosity is related to the fourth power of temperature. So temperature to the fourth power. Okay, that's so you can see that a small change in temperature makes a massive difference to the intrinsic brightness of the star. So Betelgeuse getting less bright, it should be contracting. When it contracts, it should rise in temperature, and it should turn a little bit bluer, more toward the hotter end of the spectrum because it's getting hotter. But we're not seeing that. Not only that, it's getting dimmer, but we're not seeing a rise in luminosity because the luminosity depends, as I said, on the fourth power of temperature, and temperature should be increasing. So why is the luminosity not rising?
Yeah.
It could be because the radius is radically shrinking. And if the radius is radically shrinking at 700 light years away, this supergiant, which normally goes out to the orbit of Jupiter nearly, if you put it where the sun is, maybe it's only going out to Mars, or maybe the asteroid belt, in between Jupiter and Mars, or maybe something a little less than Mars. And that would also alter the luminosity and make up for the fact that the temperature is increasing to increase the brightness. So it's an odd combination, and we're not sure why it's happening. And I just love it. I love
exactly.
I love
do you have
not knowing.
Do you have a theory?
Well, since you asked,
I did.
I'm thinking that perhaps the reason that the reason that Betelgeuse is dimming most definitely has to do with the fact that the radius is decreasing. However, Betelgeuse is doing something else that we know about. It is losing mass. It's giving off lots and lots of mass. It's lost more than one of our sun's masses. Okay, and it was a 20 solar mass star. Betelgeuse, in fact, was a star that was very much almost identical to another one in Orion before it became a supergiant. And that star we're talking about is down here, and it's called Alnitak. Alnitak is this star here, and Alnitak, Zeta Orionis, is actually an O9.5. That is on the color scale of OBAFGKM.
Yes.
The O stars are the hottest and the bluest. That's Alnitak. All right. Alnitak is only a few million years old. All right. And it's actually a star that is similar in spectral type, that is the colors and all that, to what Betelgeuse was before it became a supergiant. Isn't that amazing?
Interesting.
Yeah. I do want to stop here and just say I said hi to Kimmy, but I make sure I did. And I want to say hi to and Trish D. Hi Trish, thanks
Trish.
Trish made such a nice comment on the on one of our streams. It was very kind of her. I have Carol Carl with me, the KGRA radio host of Behind the Obsidian Curtain, which is on Fridays at 7 p.m. and whoa, Elliot Astro Imaging, dude, where have you been? Been looking for you.
Well, he's here now, or she.
He is.
Hello,
and
Elliot.
Tim F. I didn't see.
Yes, Tim F.
I didn't see you, Tim.
Oh.
Sorry, man. Yeah. So yeah, it's really cool you guys came out. I'm glad you guys are here. If you have any questions, please do dump them in. We're watching Betelgeuse right now. As I said in the title of the stream, spoiler, we're probably not going to see it blow up tonight. But boy, wouldn't that be fun if we did, huh? Oh, it's like wowee, man.
Now, I'm just gonna. Can I just ask you what would be the consequences? How would that? It wouldn't be like a sci-fi film and that's the beginning of the end, or the cosmos is exploding here. But what would be on planet Earth? What would be the ramifications of us seeing Betelgeuse right now going?
Well, how
would it affect our life here, or would it?
Oh, it would tremendously affect the where our telescopes point. It wouldn't affect anything on Earth physically. It wouldn't have any effect if that star went supernova. I mean, there's a lot of us that can't wait to see that, actually. We would hope it would. It's so far away that it would not bother us in the slightest. However, it would be a bright star, so bright that it would overwhelm the sensor on this camera. Yeah, and to the point where it would actually be so unbelievably bright that we probably would have to, take a picture at like an 8,000th of a second to actually see it as a dot like this. It would be very bright. In fact, it would be so bright you'd see it in the daytime with your eyes. If you went out, you'd see it in the daytime. And that could last for anywhere from a couple of weeks to a couple of months to a year.
That was my next question.
Yeah.
How in real time, how long that would persist?
It could last up to a year. And we know that when the Crab Nebula went off in 1054 AD, it was visible as a daytime star for a year.
A year.
Mm-hmm.
Ho ho.
Yep. I mean, that's a very powerful stellar cataclysm.
Yeah.
Yep.
That must have freaked everybody out back then.
Yep. Yeah. And I want to say to Elliot, good deal, Elliot. You do what you got to do. I don't know if you heard, but to Elliot, I'm telling him, hey, Flames of War, I didn't see you. And Marco, hi.
Marco.
Yep. Polo. I want to just say to those that don't know, SkyTour LiveStream has a new telescope. We're using it now, but we're testing it here in the Connecticut site. That's northeastern United States, for those that are overseas or down south in Mexico. And the thing with that is that our system is being moved to a site in Arizona, and SkyTour LiveStream will have two sites. We'll have SkyTour LiveStream East, and we'll have SkyTour LiveStream West. So 2 observatories will be doing all this wonderful viewing for your pleasure. So we're looking forward to that.
How cool is that?
Oh, it's wonderful. In fact, we're going to be, in February, I'm going out there. At the end of February, we're going to be out there for several days to pour the foundation for the other building. Yeah.
Wow.
Putting in
now,
the
I'm
piers.
hoping all this will be videoed, etc., and we'll be able to see that pour.
Oh, yes, it's going to all be videoed. Absolutely. In fact, if I could live stream it, I will. But I have to run the internet system out to the dome. The dome's on an isolated 5-acre spread, so I'm going to have to do that. But the other thing about this dome is it's going to be run off the grid entirely. There's going to be solar panels and windmills that power the dome. Nothing else.
Excellent.
Yep. Yeah, so it's really good.
So if the grid goes down, that will stay up.
Oh, will. Sure.
Yeah. Wow.
Yeah. Yeah, and if the world ends, we'll be able to still do this.
Yeah.
Yeah, we'll be able to do this. Yeah. Yeah, really. It's good.
Oh, it's all good. Mm-hmm.
Yeah. Yeah. So I'm just going to try to take us to here. This might not... I may have to move the dome because I know that this is close. But I want to take us to the Orion Nebula just so people can see the Orion Nebula tonight. There goes Betelgeuse. It'll be back. Or as my friend Arnold says, I'll be back.
Yeah.
I'll be back.
Yes, our California former governor.
That's right. And now the high precision slewing lines up on Saif. And that's this star right here. And so you can see the telescope going there in the planetarium. And then here it's there. And it's going to center it. And then from there it's going to plow on up to the Orion Nebula.
Speed the plow.
Mm-hmm.
Uh-huh.
Yeah, I decided to leave the high precision system on. I could turn it off, but the high precision is needed because some of the things that we do require some really delicate finding, and we're using a telescope with a much higher, a smaller, I should say, field of view. And there's the Orion Nebula right there.
Oh my God.
Yeah. So Orion is coming in here, and you can see it's right here, and so the trapezium is that bright area on the image, It's those little 4 stars that you see right there. It's just an amazingly beautiful location. And the Orion Nebula is an amazing place because it actually is doing some. It's actually a place where stars are being born. You know. Yeah. And
the little nursery, right?
it is a stellar nursery. That's what we call it. Yep. Yep. Indeed. So now, right now, what's happening is in the telescope. What's happening is the system is finding a guide star and locking onto it, and it usually locks on after about 15 seconds. So if I'm gonna do this photo. It doesn't look like much, does it? But that belies what's really going on under here. So I'm gonna do this. I'm gonna move this here and then move this up a little more. Okay. That sounds like dinner music.
It really does. Waiter, more wine.
Yes.
Okay.
Yes. We'll be right back. So let me. Let's. I assume we're locked on now. I'm going to do a 30-second shot at 10,000, which is way more than we need for the Orion Nebula. But I wanted to show you the delicate gossamer structure out here. So let's make it work. So off we go. And then we'll. No, actually, now it sounds like a Peanuts cartoon, with Charlie Brown.
It does, yeah.
Yeah. Snoopy!
I may as well tell you now, Charlie Brown.
Yeah. Hey, Genghis, good to see you. Yeah. Sergeant Quinn, what's happened? Yeah, it's at the Stellar Baby Factory. That's exactly right.
Yeah.
In fact, the Orion Nebula is got a lot of young stars in it. And young stars, some of them are known as T-Tauri stars. This is I tried it. As you can see, there's a little red. That's the dome that is interfering. I have a red light in the dome so that we can always tell if the dome is interfering with the shot, and it is. So I'll have to move the dome, but that's okay. I don't mind. Anything for you guys.
You just give us so much.
Yeah, a little.
I hear my cell phone. Sorry.
No, it's okay. A little instant processing there. You can see a little difference right away. So I'm going to have to go move the dome. Do you guys mind if I just go do that real fast? I will.
We'll just talk amongst ourselves here.
Yeah.
So,
keep everybody happy. I'll be right back.
Try to do that.
As soon
Genghis
as
Khan.
Yeah,
Hey,
Genghis is
Debbie.
here, yeah.
Debbie Ahern is here.
Debbie, hey, and Do-W. Good to
Yeah,
see you
Do-W.
guys. I'm so glad you guys came. All right, I'll be right back. Dave Schmidt.
There he is.
That's our guy in Bangkok.
He survived his break. Yes.
That's our guy in Bangkok. All right.
Was he? I just
will be
wondered,
right
David,
back.
were you stopped by the PD?
No.
Aha.
All right, I'll be right back.
All right, we'll be right here. Sergeant Quinn. Yes, it is gorgeous, Elliot Astro Imaging. It is not my discipline. I am learning so much. It is absolutely fantastic. This is sort of the best live, internet education one could ever get. There's nothing like it. Yeah, boy, I just don't know. So lucky to stumble upon all of this. It is invaluable, right? And look at that, the gossamer, as he was saying, even with the dome interfering, you can still see all that filigree stuff. It is wondrous. Yeah, just astonishing. Now, there's a lot of theory about what's going on with Betelgeuse. I did just a little kind of 10-minute web search and listened to some theories from people. It's funny. I'm thinking I should write down who these astronomers are with all of their Betelgeuse talk and what's going on. Write down those names and see if I can vet them with Mark, and then I'll know whether or not they know what they are speaking of, etc. Mesmerizing, Kimmy. That's absolutely the word. Yeah. Quite amazing. Tim F. never misses a live stream. Yes, he loves it. Mark is a great teacher. Absolutely. That is undeniable. Because, he, for instance, who here is shy? Raise your hands about asking Mark what you think would be an ignorant question. Well, you see, that's just, he doesn't do that. He doesn't present like that. I hear shuffling. Mark, are you back?
Yeah.
No. Yes, he is. There he is. We were just singing your praises.
Oh.
I know. That makes you uncomfortable. All right. Well,
It's
look
okay.
at that image.
Well,
though.
I do have to do it again. And unfortunately, I'm noticing that we have some clouds out there.
Ah.
Well, you know how I saw them?
Hmm.
I saw them right here.
Oh.
I saw that there was a bit of a fuzz
Yeah.
softening my view, and as it turns out, it's clouds. Now, the dome was in the way, but let's see what we get. We're taking another 30-second shot here.
It's so interesting, something that is not in motion, but honestly, those images you can almost like that. We can. I mean, can't you feel it moving in a sense?
Oh yeah.
Yeah.
Yeah, in a sense, yeah. So, because we're looking through some light cloud cover now, delicate wisps are not as bright. Let's see if we can draw them out. No, okay, it's not really as bright. Trying to draw them through for you.
Aha.
Yeah, they're still not there. They're down here. And I'll tell you, I'll show you actually. You know, when some of you probably missed when you first came on, I had some photos, or a photo that I was showing you, and it was this guy right here. All right, this was the welcome screen tonight, and that's Measure 33, Galaxy and Triangulum. I shot that 2 nights ago. It's really, it's really beautiful. You can see this here is the equivalent of the Eta Carina Nebula. The equivalent of the Orion Nebula is one of these many other star forming regions in here, like this one here, or this one out here. And one of the other things is these little dots you see here, those aren't stars in this galaxy. You can't see the individual stars in this galaxy. It's over 2 million light years away. Those are globular clusters in this galaxy.
Wow.
These are globular clusters. And so that's what's really interesting about this particular galaxy. Who lives out here in this part of the spiral arm where there's a H2 region out here, and it seems to be breaking away from the galaxy, and it's way out here. You know, can you imagine if you were interstellar? It's like, hey, come on, man, you're leaving me behind. Hey, D. Smith.
Running along to catch up.
Yeah. So yeah, that's one that we took the other night. Another one that we took the other night is the Andromeda Galaxy, and I will show you that. Now, I didn't stream that night. I actually did. It was a personal night, just a night that I wanted to try this myself, just try a few things. And this is now the Andromeda Galaxy. Okay. This is now, you can see Andromeda with one of its companion elliptical galaxies. Tons and tons of dark clouds in here. Much of this is dust, dark dust, and the nucleus of the galaxy is here. And this particular telescope, these are 1 minute photos, by the way. Normally we take, 20 seconds, 30 seconds max. This is 1 minute. Okay, so... Brock, you know an alien from there? Oh, man. Yeah.
Introduce us.
Yeah, it's like, I'm from Andromeda. Do you know,
Yeah, I used to live a block away.
Right. Can you imagine?
Actually, I can imagine.
Hey, I want to say hi to Joan S. Hi, Joan. I don't...
Yes, she says, and Joan says, who needs ASMR vids when you have this? ASMR, let's see if I learned that. Auto stimulus meridian response or something like that. Yeah, there's a lot of a lot of vids online.
Wow, that's cool.
Absolutely true. Yeah. Who needs that, Joan?
And this by the way, not that one, but actually, yeah, this one. This is a raw image of that we took. Then I took several of those, and then I stacked them together, and that got this. Then I took those in and processed them, and I got this. So you see, it's a several-step process. This is the stacked image that comes out of having many images that you put together.
So in other words, those are like, for instance, in old-fashioned animation before CGI, putting layers one on top of the other. Is that
correct.
What you're talking about?
Exactly right.
Okay, that's stacking. All right,
so
got
it's
it.
stacking. Yeah. So if I just flip this around for you. So this is the same way. This is a raw shot. This is what I saw in the camera after I took the picture for 1 minute. Okay. Then why'd you do that? Then it did this. Okay. When you stack them all together, you see how you get more detail. Then finally you end up with that. I mean, that's really cool.
That's very dramatic.
Yeah, very dramatic difference. Okay. And then let's see. Now, the other night I also took pictures of. Beyond that, I actually took a picture of this Messier 42. That is the Orion Nebula that we were looking at tonight. And this is how that came out. Okay.
Oh
So
my
you can
God!
see
The depth is astonishing.
you can see the wisps now, and you can see there's stuff out here. This is also you've got some dark nebula in here, which is actually dark dust, and here is a little tongue of this stuff sticking over the bright nebula behind it. Okay, this is a stellar nursery like we talked about, and Orion. Okay, there's the tongue I was talking about, and over here the dark stuff.
Yeah.
And you know what? My favorite part of the nebula, my favorite part. Are you ready for this?
Ready?
It is this little spot with these little stars, these 4 stars right here.
Oh my gosh.
Those little 4 stars right there. Now, the thing that's interesting is, if these are in the nebula, as I suspect they are, then it means that this little void, this area of no material or less material, probably is because these stars were born here and they blew away with their stellar winds, especially when they're young, blew away a lot of the dust, and you're seeing it in action here.
That was my question, was what the source of the dust was.
Well, the source of the dust is actually, it's pretty well understood, but I can tell everybody.
No, silly person here, but no, I have an ignorance about this particular thing. So maybe somebody else out there might as well.
Yeah, no, that's fine. And there's never a stupid question.
Yeah,
and there's no ignorance in astronomy, trust me. Because even astronomers will be surprised by things they thought they knew, and they didn't. Such as, why is the brightest star in Orion, that's supposed to be the brightest star, fading out of view, Yeah. So, but these stellar nurseries and the way that the dust grains, the way you get this black dust in space, it's not black. It's just that there's no light that's hitting it at this point.
I see.
Yeah, because when light does hit it, then we see it because it scatters the starlight, and those are very blue nebulae called reflection nebula. So things like the Running Man, the Pleiades have this. In fact, I can show you the Pleiades with one of those exactly like that. And so what happens is, as stars get older, like Betelgeuse, it's a supergiant, it's expelling its outer layers. Okay, and as it expels its outer layers, all right, we're actually seeing that its outer layers are far enough away from the star. Don't forget, the outer layers of Betelgeuse are out by Jupiter, and if you put it where our sun is. Okay.
Wow.
So it's so far away. It's so cool. It's very cool in temperature, and so these grains of dust can form out there, based on some of the molecules that are in the outer atmosphere of the star. Believe it or not, in the sun, there's no molecules. It's way too hot. In fact, the sun is plasma. You have individual protons and electrons flying around. You don't have atoms per se. So when you have a star like Betelgeuse, it's got such a distended long-range envelope that these materials in the outer atmosphere of Betelgeuse can literally leave the star when the slightest pressure behind them from radiation, pushing them, can push them away from the star, especially when they get out by this, again, it's almost like, over 6 astronomical units away from the center of the star. like they are, and that's 93 million miles times 6. So it's a
Aha.
long way. So that said, I think that you kind of get an idea of how it works. So what happens is when they get far away from the star, the material leaves the star, and some of it can do what's called it becomes a condensate. It condenses out of the stellar material that used to be there, and when it cools, it can form, I won't call it ash, but it'll be like little tiny grains, little tiny spindles of dust. And it's a particular kind of dust that forms, and that dust is what we see as this black stuff here. Okay.
Wow.
And you might notice actually that it seems to continue past this area, and it certainly does. It goes all throughout here. In fact, if you want to think of it correctly, the entire Orion Nebula is like a blister on a large molecular cloud. Okay, a large black molecular cloud of dust and other gas. And because of the trapezium, what's the trapezium? Remember, it's those bright stars that are actually, let me just get you to it real quick. The bright stars, which are actually those 4 stars you see in the center of the Orion Nebula, right there. Let me see if I can get us in closer. Okay, yeah, we can do this. I'll just grab my controller and bring it down. Okay, so those stars you're looking at right there, that's the trapezium. Those are those 4 hot young stars in the middle of the Orion Nebula. And those are the guys that are powering a lot of the nebula. Right? Very, very hot young stars. They have a lot of ultraviolet radiation. So they're slamming into, with their radiation, it slams into the hydrogen atoms in the Orion Nebula. Where are those? Well, those are everywhere that we see in here. Let me just do this. Okay? Those are everywhere in the Orion Nebula. In fact, if we come back to our other view of the Orion Nebula we took the other night, you can see it now. All right?
Yes, right.
Okay, you can see now how these hydrogen atoms will be ionized. That is, they only have one electron. When that electron is so excited by this ultraviolet radiation that they are absorbing, that they bounce off the atom, well, they spontaneously will bump into other things, and then they'll start dropping into whatever atom is available, and that atom might be, well, it will be usually another hydrogen atom. When it does that, it cascades down, dung, 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 into the atom to these very discrete energy states. Okay? And when it gets to an energy state we know as n equals 2, that's n as in number, n equals 2, that state, the atoms predominantly stop there. Some continue, some stop earlier, but most of them stop at n equals 2. And when they do, they give off light. Okay? That final release of energy, they give off light. And that light...
So in other words, what propels them to, or that's the wrong word, but what causes them to stop also produces energy.
Well,
yes?
it's actually...
No.
They're actually, as they drop into the atom, they're losing energy. And to stop, they have to reduce their energy even more. So when they finally get recombined with the atom, it's called recombination, as a matter of fact, then they give off this light. And when the predominant transition, it's called, is that these electrons drop into the n equals 2 position, okay, that little location in the atom, where energy level that's a fairly common stopping point, they give off a characteristic red light. And that's something we call hydrogen alpha. All right? And so when we call these H2 regions, it's H Roman numeral 2, HII, right?
Right.
Well, why don't we just call them H1 regions? Because why would we say 2 if it's only 1 electron? How can it be? Does that mean doubly ionized? Well, it means singly ionized. And this is where we love to fool everybody and love to make people think. H1, H Roman numeral 1, so HI, all right, is the base state of the atom. It's the one with the proton and the electron. All right, so it's already starting at 1. So when you ionize once, it becomes H2.
Aha, got it.
And it works with oxygen that way too. This blue area here is actually oxygen that you're seeing now. Okay, now this is sort of a teal blue. It's not really a bright blue, is it?
Right.
Yeah, this is what's called doubly ionized oxygen. So if it's doubly ionized, it's an O for oxygen. But what's the Roman numeral? Do you know? You can think of it. You can figure it out now. If doubly ionized is H2.
Okay, would it be 3?
Yes, it would.
Aha, what do you know?
It would be O3. Because its O1 is oxygen with all of its electrons. O2 is oxygen where one electron has been bounced off. And O3, the predominant line that we see in these nebulae, is where 2 electrons get bounced off. And when they recombine, they go to one particular energy state overall. They go to others, but the predominant one that overtakes all the others visually is the state that creates this teal blue color when they finally come to rest in the atom again. And that's what this is all about. Okay? And that is how these H2 regions work. Now, on the other hand, what about when we talk about regions where it's actually bright blue? I mean, there is some places where we see bright blue, and bright blue. Hey, what's that? Well, here's an example of bright blue. This is a close-up of one area of the Pleiades, okay? And you'll notice that there's this blue, almost combed, as Daryl says, combed dust we're seeing. This is actually dust. It's not ionized material. Yes, these stars are hot, but this is dust. It's not gas. And so what happens is when these stars' light hits the dust particles will absorb the many different frequencies of light from the star. But predominantly, they will allow most of them essentially to pass by. But the blue light, for some reason, is a very high energy light, and the dust will interact with it. And then once that part of the blue light from the spectrum of that star goes into the dust, it goes in. The dust will radiate away the blue light in all directions. And so, in other words, it scatters the light, the blue part of the light, in all directions. The reason we see this blue nebula is the same reason we have a blue sky. Okay, because in the case of this, it's a dust grain, but in the case of our atmosphere, it's the nitrogen and oxygen molecules in our atmosphere that absorb the higher frequency light and then shoot it out in all directions. So typically, this is the reason why when we see a sunset, it looks orange, because we're seeing the sun through more atmosphere. And so more of the light has a chance to be scattered in the blue part. And when you take out the blue in a spectrum of red, orange, yellow, green, blue, you're left with red, orange, yellow, and green predominantly. And you'll see mostly the red and the orange. Okay? And so that's why sunsets are blue. I'm sorry, why sunsets are red. Yeah. So yeah, it's actually pretty cool, Hey, Eugene Belforche, he is out in a wonderful little area. Belforche is in Wyoming, near Devil's Tower and Hewlett.
Oh, great site.
Yeah, Eugene Schnitger, he's a really nice guy. Spent some nice time with him. He's really a fantastic guy. And as you can see, he likes astronomy,
Yeah, and now he's here.
And now he's here, yeah. So this is the difference between when we talk about a reflection nebula versus an emission nebula. And now you even know that this is not really technically reflection, it's more of scattering, I guess you can call it reflection in a sense, but it's really a scattering nebula, So that's that. And I shot this the other night too. So
beautiful.
Yeah, well, see, the thing is, a lot of these things that we do, I could always go to like a book and see a book, but why? When I got the sky, I have the sky. I can do it.
Yeah.
Yeah. Now, I'll give you an example. This is like the Orion Nebula. This is another nebula that I took a photo of just several days ago. This one is called the Flaming Star Nebula.
Oh.
And if you notice, it has this blue in it, and it has the red, this is the hydrogen emission that we're familiar with, like the Orion Nebula, okay? But it has this blue in it because part of it is dust that's being scattered. Dust that's scattering the blue light from this star here. This is in the constellation of Auriga. Now, this nebula is extensive, and I'm showing this part of it. You can actually see how beautiful that looks. And it's called a flaming star because it looks like the star is flaming right here. It's like it's burning, see?
It does. It does.
Yep. W, thank you for coming. I'm really happy you stopped by. Do lay down and take care of yourself. And Cleo, nice to see you. Welcome. Cleo has joined us. And you'll notice I always make a habit. I like to talk to whoever's out there.
I have noticed that is the best.
Well, I just think that,
talk about an inclusive feeling for everybody watching and participating. That is just, that rocks.
If they're going to spend time to come see this, they should be, rewarded.
Yeah. Here's a tiny reward for David Schmidt, I guess. I'll toss this. He believes that the Orion Nebula, I think, was that the one, looks to him like a ballerina in a pink tutu, perhaps on a motorcycle with a pink helmet.
Okay.
Okay, I just had to throw that out.
I actually heard people say, "Oh, it looks like an angel. It looks like."
Yeah.
I see some of those things. I see what they're talking about for sure.
Yeah.
But yeah. So here it is, and when you look at it, let's not do 30 seconds. I'll show you. This is better. I'm gonna do 30 seconds, but I'm gonna go down to 4,000. ISO and do a 30-second shot. Okay, we should have reacquired now. Our guider has got everything we need. And if you were here earlier, you noticed that we had a star in the view. I forget which one it was. It might have been Betelgeuse, maybe. And a satellite was just going slowly through the field of view. It was really cool.
It was amazing.
Yeah, it was pretty. So it was kind of cool. That said, I'm gonna take this shot and see what we got. Hopefully it'll look okay. That is to say, if sorry, a little overmodulation there. I talked too loud. If the dome is not in the way, I don't think it is. I think I moved it enough. So we'll see.
Flames of War is here.
Oh, Flames, how you doing? Ah, yes.
Oh,
yeah,
boy.
Yeah. So now we can see. Now here's what I like to show with this. Okay, most of the photos you see of the Orion Nebula, this center part is all washed out and it's white. Okay, by cutting it down to 4,000, you still get to see some of the cool stuff on the outside, but you also can see the mottled area in the inside. Now this is oxygen in here. Okay, this is definitely the oxygen 3 in here. See that color?
Wow, yeah.
It's really rich, It's just something else. Yes, so it is beautiful, yeah. So now if I go back to, our view here, and I go even lower, and I say, let's take us down to 2,000. So that's 2 more photographic stops. I'll even go down another one to go down to 1,600. Now we'll do a 30-second shot. Now we should be able to see the trapezium as 4 beautiful stars with the modeling and some of this. And by the way, I gotta say hi to Tara, who's here. Tara, how you doing? I have not forgotten about you, and I'm gonna send you that copy I promised you. Tara was very good about helping me edit my book. She literally went through the book and she found probably every single error I made.
Oh my! Yes, I remember you mentioning her before. Yeah. Right? Yeah. God, what a contribution, Tara. Mm.
Yeah, she did. She was really good about it, and I want to thank you. This is public thanks to her right now. I'm not afraid to give credit where credit is due. Never have. Have never have been. So there you go. Look at this. Now we see the trapezium. We see the modeling of the O3 in here, this doubly ionized oxygen. We see this dark nebula here that's coming in here, that's dust. And we see other stars. And, of course, my favorite 4 stars right here. Look at that. 1, 2, 3, actually. The fourth one is up there. But still, isn't it pretty?
Pretty is, yeah, it is. I would say yes. Oh, pretty. Pretty amazing.
Oh, Tara, thank you so much. I'm glad you liked the book, Tara.
Oh, it's a great book, by the way.
Yeah, I'm glad that you think so. Because I might be asking you to help with an audiobook.
Well, gee, I don't know. I think I have to wash my hair or something. I don't know. Delightful. The most delightful concept.
And I base it on the fact that you offered.
Yeah, I was going to say yes. It was like, hello, right over here. Okay. Mm-hmm.
Okay, David Schmidt asked a question. What keeps them from slamming into each other? I've never seen stars that... Oh, you know what, though, David? They do seem close, don't they? But I got to tell you, you would think that in a globular cluster that the stars might actually hit each other, right? That's more likely where I would expect them to hit. Because that is an extremely complex set of orbits that they're doing in there, because they're all gravitationally bound to each other, and they're going through a delicate dance between each other. But when you look at a nebula like this, stars are only ever point sources. They're only looking big like this because of the fact, and I think you know this, David, they're only looking big like this because of the fact that our sensor is bloating the image as it comes in because it's bright. Technically, every one of these stars in here, the bright ones included especially, are going to be way, way smaller than these little points right here that I'm showing you. Way smaller. So they're really quite far apart in reality, considering that this is several tens of light years across this Orion Nebula. So I would think that maybe you might want to think about considering how stars are oriented in space and how they interact with each other, and it's globular clusters where it's at. That's where you're going to find problems with these stars, you know? Yeah. Elliot,
Donald Kunzer, I just want to ask, because I'm interested in this too. He wants to know, aren't there more objects beneath the nebula?
Oh, Donald, fascinating comment. Yeah, in fact, to see what's really going on inside the Orion Nebula, we have to look in more than just the visible light. When we look in the visible light, well, we see these stars, you know, here and there. Okay, but guess what? Deep inside the nebula, in certain other locations, like down in here, you can't tell, behind this dark nebula here, you can't tell that there's other stars that are actually in the process of almost getting ready to wink on and start their nuclear furnaces. And those are called protostars and T Tauri stars. These are stars that are that are very plentiful in the Orion Nebula. That's why we call it a stellar nursery, because it's actually doing a lot of nurserying. You know? Yeah. So yeah, you're right, Donald. Very, very good point. See, that's why I've always said, and the people that come to SkyTour LiveStream are among the smartest people on this darn planet. You know, and for those that feel like they can't hold a candle to someone else, just hang out for a while, and you'll be the ones holding the candles. I promise. You know. I will be. I'll make sure. You know, I can't just show you something and then say, "Wow, that's pretty," and move on. I do want to tell you about it, and you know, the subscribers. You know, we're over 3,300 subscribers now, which is just crazy.
That's wonderful.
It is beautiful, yeah, and it's precisely because people want to know science. They want to hear about science. You know, so yeah, so there's a beautiful Orion. Look at even when you look at the other parts of the nebula, you see there's patterns of structure in here. You know, it's very, very complicated patterning that we're seeing here. But these four stars are really doing the lion's share of causing this nebula to glow. Young, hot stars with ultraviolet radiation pumping out, ionizing the oxygen here, the hydrogen out there. If you think about it, if you look at this from a perspective of light years, these stars are several light years from this part of the nebula over here. Okay? And they're still causing this oxygen here to ionize and glow.
Still having an impact.
Yeah. That is impressive. Most impressive. But you are not a Jedi yet. Oh, sorry, I just sort of...
Oh, okay, well, no, but here's a chance for you to do one of your voices. Cleocatra. I just love that name. What a handle. Cleocatra says, one of my favorite Sagan quotes, when you look out into space, you look back in time. So hit it with your Carl voice.
That is actually true, and we've talked about time travel in the universe, you know. And Sagan, of course, is my favorite astronomer, and what Carol's trying to goad me into doing
yes, I am.
is to say, you know, as he would say, when we look out into the universe, we are looking back in time. You know, that's Carl Sagan. That's what he says, okay? He said, and it's true. We see the sun 8 minutes ago. We see the Orion Nebula 1,200 years ago.
Oh, baby.
Okay? We see Betelgeuse 700 years ago, which is why, if it's not there now, we won't know. If it went supernova tonight, where it sits in space, we won't see it for 700 years. Right?
Yikes.
Yes, that's the crazy part about astronomy. It's all time travel, every bit of it. Every bit of it, you know. So again, for those who are not familiar, this is the way SkyTour LiveStream is laid out. We actually have on the left side of the screen, we have operations. That's me down here. I used to be out in the dome doing this, but I decided that it was probably just a little bit too cold in the winter.
Yeah, a little bit.
So I learned how to automate the systems and run them remotely, and that's paid off big time because now I started a GoFundMe to help fund the observatory out in Arizona. I don't have land out there, but I have friends who used to work at Lawrence Livermore Laboratory, and they have desert land with full internet and off-the-grid power, and they offered me a 5-acre chunk. Not to
and
keep.
It's fenced, is that right?
It's all fenced, yeah.
Wow.
Yeah. So I'll be able to, SkyTour LiveStream West will be set up starting next month. And we're going to pour the concrete pad. It's going to be a 12 by 12 building. It went up from 10 by 10 because we're adding a second pier. And we are going to make it a flat roof building so that the roof will roll right off the entire building. And open it to the air, so we won't have a dome to worry about. There won't be any moving of a dome because I'm not going to be on site to run it. I'll be running it remotely like I'm doing here with tonight's observatory.
Yeah.
You know, we're running the camera like if I hit, you know, east here, you'll see that the nebula goes east. Okay? And that's because I have this program hooked up to that telescope. Well, this system could be 1,000, 10,000, 3,000 miles away. It does not matter. It's still going to work the same way. It's just when it's long distance, you need to have more coverage. For instance, I have to get a camera that's going to be able to look at the sky at all times, so I can see if there's a storm coming, or in Arizona's case, a dust storm.
Right.
And then shut down the telescope, close up the telescope, all remotely, and then put the roof back on. You know. Now, if you think about it, when you take a telescope out, you got to take off the cover on the end of the telescope so it can, you know, so the mirror will catch the light. Otherwise, it's covered up. So I had to write a system that uses a special motor called a stepper motor to open the cap, open the end of the telescope, and I did that. And because this particular telescope has another little telescope for guiding mounted on it, I have to have that one open too, and open that one's cover as well. So it's a little bit, it was complicated, but I figured it out and I got it to work. So now we will be actually able to open the telescope, turn on the power, get the system up and running, start up the camera, get the camera going, and it's just an amazing process that finally, after all this time, I'm able to do. I'm very, very happy about that because it took a while to figure this all out.
But it's all in your skill set, which is just that astonishes me.
Well, it's in a skill set now. It wasn't at the beginning. I had to learn it.
Ah.
Yeah. Okay, this is Betelgeuse down here. Okay. And it should just beep and stop. I was having trouble with the telescope earlier, and I'm working on ways to troubleshoot it from a distance. In other words, I could just walk outside, walk the 50 to 60 feet over to the building and go inside the dome and mess with it. But I couldn't do that if it was 2,000 miles away. Well, actually 2,500. So I have to learn how to do it this way, Okay, but see, it worked. So now I can just get us ready here. So I'm going to move us a little bit west. And right now, the auto-guiding system is locking on to stars in the area. If you look near Betelgeuse, you'll see there's a lot of stars around it.
Yeah.
And so the auto-guider is picking one, and it's locking onto it, and it's going to guide on that star. And that means that I can take longer exposures. So now that I'm thinking that we probably have what we need, I will just do a shot. We'll do 4,000, but we're going to go just for fun. And this could be dangerous. We're going to try it for a minute. And it's off. So, and adding time exposures to this was a latest addition of the software. They added the ability to do what's called bulb. And why bulb? I don't know why bulb. I mean, historically, a time exposure like that, you wouldn't set off a flash bulb. So I don't get why they call it bulb.
It's not an acronym, huh?
No, not as far as I know.
Crazy. Daniel Whitaker is here saying hello.
Hey, Daniel, how you doing? I'm just getting back to the chat now. Microscopes are terrifying.
David had a suggestion to train a capuchin monkey with a lab coat and goggles to do that remote stuff. That's hilarious.
Can you imagine that?
I can visualize it, yeah, but it's an animation. Okay.
Yeah. That's really cool. Well, I am the best capuchin monkey, so I'll be doing it for you.
Excellent.
Okay, let's see what we got. Okay, there's 1 minute of Betelgeuse at this, what did I say? We had it at 4,000, right? So now you can see all the stars. So one of these stars was the guide star. And by the way, notice how well it guides.
It does. Look at that.
Look at these little stars down here. Look at those. Okay, I got a little bit of that's something different called coma. Look at these little stars right here. Let me actually frame it for you here. Wow, that's cool.
Wow.
Yeah.
Dan Delaire says hello to everybody.
And Dan, hey, how you doing? I met Dan at a one-day astronomy or UFO actually conference in Danbury. Yep.
Yeah, Donald asks.
He's right.
Donald Kunzer, our astronomers placing bets on when Betelgeuse will go.
Here, check it out. Here's a good story for you, Donald, and for everybody. When astronomers saw on the LIGO detector, that's a laser interferometric gravitational wave observatory, LIGO, L-I-G-O, when they noticed that there was a gravitational wave that looked like it was coming from Betelgeuse, one of the astrophysicists, they saw the result and said, wait, that's coming from Betelgeuse. He ran out of his chair, ran outside to make sure Betelgeuse was still there.
Wow.
He thought it was. It thought maybe it was it a supernova? Yeah. Now, there's a interesting thing here. If Betelgeuse wasn't the cause, then it's an interesting coincidence. But if it was the cause, then you have to ask, did something happen inside of Betelgeuse that might not have caused a supernova, but did cause a cataclysmic gravitational wave? Typically, gravitational waves have been born out of very, very high energy collisions between very, very massive objects. So only a gravitational wave anomaly of that nature would be expected from a supernova, perhaps, and maybe not even. So why did they see this at Betelgeuse? Now, that's the question. So the question is, and the astronomers are kind of doubting that it's actually related to Betelgeuse and it was coincidental. I don't know. Hey, Carolina Sky, how you doing? Yep. I don't know. I don't know what to tell you, but I do know that when we look at Betelgeuse now, we're seeing it as a red supergiant star, and it's only a matter of time before it will no longer be there. Yep, and that is something that I don't think that's something that well, I won't miss it. I want to see the I really want to see the the supernova, because the remnant left behind will just be outstanding.
Oh.
Yeah.
How would that present itself, do you think?
Well, it'll be, of course, a very bright star, and then once the brightness dies down, we'll be able to catch early on in the next months or two. We'll be able to see the beginnings of a supernova remnant. At 700 light years, it's pretty close. Crab Nebula is more than that. It's, I think, a few thousand light years away. And this one's only 700. So it stands to be a fairly large remnant that we'll see. There's a large remnant now in our sky in the summertime, and it's right over your head in August around 9 o'clock. It's called the Veil Supernova Remnant, and it's bigger than the full moon. But the thing is, it's also just under 2,000 light years away. This one is 700 light years away. So this Betelgeuse could leave a remnant that's literally several full moons in size.
Wow.
Could be, yep.
Oh my God.
Yeah. But it won't be instant either. We'll watch it develop. And because it's so close, we'll actually see it develop. Like when we watch Betelgeuse, again, I just can't wait. Wow.
Right, I know.
I mean, it's like I don't want to take my eyes off it, right?
Right.
Yeah.
So in other words, we could be looking at along with the potential of a space weather report, we could be looking at an evening Betelgeuse report on our news, yes?
That's exactly right.
Yeah.
I can answer Daniel's question. Yeah. How much lead time would the gravity wave have if it were a supernova? Well, okay, I get the question. I know what you mean. One of the problems is that when you look at gravitational waves, they're usually associated with these big cataclysmic collisions between very, very massive objects, right? But when you look at a supernova, you have expectations of what you will see with a supernova. Could there be a gravitational wave anomaly before the supernova? Maybe. Okay, possibly. I can't say. But I do, because we've never actually had the ability to detect gravitational waves until, several years in the past with the LIGOs and the Virgo detectors. But we do have the ability to figure out what a supernova gives off. One of the things we don't see is neutrinos. These are high energy particles that we would expect from a supernova, and we don't see those. So we know that neutrinos, which of course would move at the same speed as gravitational waves, neutrinos aren't present. So that is what's telling astronomers it may not be related to the Betelgeuse itself. But what's causing it? Why would we see gravitational waves? Maybe, and this is another thought that was put out there, the gravitational wave that they thought was detected was an error. Maybe it was an error.
Really?
Maybe, but they don't know. So we'll see.
Okay, here's a question I'm not quite sure how to frame. How many separate facilities took that information?
Well,
does that make any sense?
Yeah, no, it does. There's in the United States we have 2 LIGO detectors. One's in Oregon, one's in Louisiana. Then there's one in Italy, and it's possible that that the 2 in the United States saw the gravitational wave. I don't know about the one in Italy. It may have. It probably did. I think that the gravitational waves just they blanket the entire Earth when they come through. So I think you could see it from wherever you are, even if you're on the other side of the planet.
So the waves were picked up and confirmed by at least 2 that you know of facilities?
I don't even know the answer to who actually did detect it.
Okay.
I don't know who detected it first, because that does help us figure out where it's coming from. Mm-hmm. If we only had one, we'd know that, hey, it just came from somewhere in the sky. we wouldn't know where it came from. But if we looked at I think Rock's gonna look that up.
Ooh, excellent.
But if we had several that are listening to the sky, they could tell us based on the timings. That'll help us figure out where it's coming from.
Sort of an astronomical triangulation?
Exactly. So.
Okay.
Yep. Exactly. So, yeah. So I think that Betelgeuse is worth staring at, but there's not much going on here tonight. And I really do feel like it's weird, but I almost don't want to put it away.
Yeah.
As I wonder whether it's actually gonna go off on us, and when I'm not looking at it, and I'll be like, no,
all right, I missed it. Okay.
How dare you? But maybe. Oh, you know what? This is cool. This is let's go to this little cluster and hang out with this. This is give you an idea.
Hanging out in the cluster with Mark D'Antonio.
Well, sorta, yeah.
Yeah.
All right, so we should. I think it's centering up Betelgeuse. Yes, and then it's going. Okay.
And while that's happening, Daisy and Zoe Amethyst
say,
Daisy. Don't blink. They say, don't blink, right?
I know.
Yeah, okay.
Hey, Jax. Thanks for coming out. Cleo Cat, I said hi to you, right? I really hope I did. And then Daisy and Zoe, hello. You guys show up here religiously. That's fantastic. I love having people come out to hang out here. We're going to a cluster up here in the sky that is called the 37 cluster. And you'll see why when we actually take the photo.
Cleocatra says yes, you did say hello.
Oh, good.
All right.
Yeah, I don't like not saying hello to people who take the time to come out here. They are certainly worthy of more than that. All right, so I'm going to do this real quick. We'll do a 10-second shot at 4,000. No, I'll do this at 6,400. I'll just take it now and see what we get. We should be able to see this cluster now. Right about now.
Oh.
Do you see the 37?
Oh, wow.
1, there's a 3.
Yeah.
And there's the 7.
Yeah.
That's why it's called the 37 cluster. Isn't that wild?
Just astonishing.
Yeah, it's a fun little cluster. And if I take a little more a deeper shot of it, then it'll be more clear. And in the other telescope, it's really quite small. I haven't imaged this in the new scope here. So I'm going to try that. I'll try that now.
Ooh, cool.
Actually, I'm going to also just take us up 2 stops and go up to 13 seconds. All right, 10,000 at 13 seconds. Off we go. Hopefully I didn't do that before the telescope caught onto a guide star.
I guess we'll find out.
Well, we'll see, right?
Yeah.
Okay, here we go. There we go, look.
Oh, my.
Yeah, the cluster is really an astonishing little cluster. I absolutely think it's just so surreal, Well, we got some motion
The
there.
shapes are... It almost looks like,
little,
to this untrained eye,
it
almost
there.
looks like one of the dippers. A little bit like the Little Dipper.
Yeah. I'm going to take another picture.
Okay.
Because a telescope had not locked on yet. That's why it was a little bit dragged out. Let me take a look at what it's looking like. Yeah, it's... maybe it's okay. Okay, let's try it. I cannot tell. See, that's the problem with the dome. You got to make sure that the opening is aligned exactly right, so the telescope can see through it and the guiding system can see through it.
Right.
Yeah, that's better. Okay, so now it looks better. Wow, that is just beautiful. What a beautiful little cluster. You know, and that's
it's so delicate, and it's I know the word compactness occurs to me.
I know. And still, okay, still one of the things that you'd find is what this cluster is full of young hot stars that you couldn't get near because they would kill you. Their radiation is really, really high. You know, so that's pretty bad.
Yeah.
Yeah. Let's try this guy here. So let's see where he's gonna go. Which star is he gonna use? Looks like it's using Betelgeuse as a jumping off point.
The underscoring music here is perfect.
Isn't it?
Yeah.
Yeah, thanks for coming, Elliot. It's really nice to have you here. So Betelgeuse is now lining up.
Yeah.
I can just hear like a big, deep roar, you know. Wait!
Right.
Don't go away.
And you provide sound effects too. That's great.
Yeah. All right, let's see now. I may be trying to do some more alignment here. All right, let's check it out. Okay. Now we're going to do 15 seconds at 12,500, 800, and give the telescope a chance to get it.
The waiting.
I know, it's always like maddening. It's like, take the picture already. Okay, all right.
Such suspense.
Yeah, it is. By the way, in the search for whether string theory is real or not, it appears. Look at that beautiful cluster. This is what I love.
Oh my God!
It appears that one of the tests that they tried to institute to show whether it actually exists or not did not pass the test. So,
really?
Yeah.
Oh, listen, that bums me out. I just
it just means
it would have explained so much.
Yeah, I know. It just means that we're not there yet.
Yeah.
Now here's something interesting here. This beautiful little cluster is made of these hot young blue stars, and then right there you have this orange star. See it?
Yeah. So what's up with that?
Okay, let me get us down to it again. So right there we have this orange star. It's really bright compared to the rest of these stars. So is this one. Okay, so is that one. So is that one. So you say, what's going on? What's going on actually is that this cluster is farther away, and these stars are very likely in the foreground.
So it's an issue of perspective.
Exactly right.
Yeah.
And that's another thing we deal with in the universe. We deal with this perspective issue all the time. Because, for instance, you look at the Eye of the Bull, Aldebaran. It's associated with a cluster of stars called the Hyades. But the Hyades and Aldebaran are two radically different distances from each other. So they're not associated with each other at all. It's just that they're line of sight associated, and that makes that's the thing that makes things into patterns that we recognize. If you saw the stars of Orion, you'd find Betelgeuse is 700 light years away. It's actually closer than many of the other stars in Orion.
So it's like, okay, like, I don't know, here's a silly thing, but it's the universe's stacking system that makes us... Yeah, no?
I'm not sure
I don't know,
what you mean.
That's a stretch, but what I meant was, in terms of perspective.
Yeah, see,
it's like...
I don't know what you mean by that, but I just like Gingus's comment here. This is the glitter bomb cluster.
Oh, well, hey, that's it. Forget it. Forget what I said.
Really,
The glitter
really,
bomb.
really, really nicely done. I like that one. Well done.
Excellent.
Yeah. Yes, sirree. So yeah, so this is beautiful. You can see how the cluster here is fairly compact, and you'll notice there's another one over here. Now, stars are all born in clusters, but what about these stars? Where did they come from? Well, they were in clusters too, likely, and then they migrated away from the clusters because, you know, the universe has time aplenty, and the gravitational interactions between these stars, okay, some of these are gravitationally bound to each other. They're going to whip around each other and finally eject themselves from the cluster, you know, shoom, and be gone, shing, be gone. And over time, clusters tend to dissipate. Give you an example. Our sun formed in what we think had to be a cluster. When you look out at the night sky, there's a bunch of stars that you seem to think are fairly bright. Now, the stars that are like Betelgeuse are exceptions because they're supergiants. So they can be seen as bright stars even if they're far away. But there's stars out there that are just sort of like regular average brightness. And it seems that maybe we were born in a cluster possibly with those stars. And some of those stars happen to be in Ursa Major, the Great Bear. That is the constellation where the Big Dipper is.
Right.
But it doesn't necessarily mean that we were born with the Big Dipper stars, but maybe we were born with some of the stars in Ursa Major, which is kind of cool. And remember, we're a nondescript star. We don't stand out. You know, our poor sun, he must have a complex. You know, we don't stand
maybe
out.
that explains all those flares.
Yeah, it's like look at me, look at me,
Right.
look at me.
I'm over here. Right.
I'm over here. Yeah. Let's see where my telescope's pointing. All right, it looks like I can go to the right a little bit. Let me just make sure. Yeah, maybe. Let's just try something. I want to just see if we can... I don't want to get too far away, but... I wonder if I can see this. I wonder if I can come up here and check it out. Here we go. I will try. If we can see the 37, maybe we can see that. And what is that I'm talking about? Well, it's a supernova remnant.
Ah.
Yeah. Okay, and now we're moving to what should be the Crab Nebula.
Ooh.
Yes. Nancy, you're funny. X-Lax does make things flow, especially when someone steals your brownies over and over from school, so you end up putting X-Lax in the brownies.
Yeah, I've heard those anecdotes.
I witnessed those anecdotes.
Oh, seriously?
Oh, yeah. I wasn't part of it, but...
Well, that's good.
Yeah. Okay, so we should be at the Crab Nebula now. Let's try... Let's just take a risk. Actually, I'm going to go into 4K mode here. Just do a quick video and see if I can actually see it.
Cleocatra says it's fascinating to wonder what other civilizations are seeing these stars as part of the constellation in their own planet's
That's
skies.
exactly right.
Oh, yeah.
Exactly right. Let me see if I can... I'm just doing a little test here. It's not necessarily a valid test. I just want to see if I can... Crab Nebula is pretty faint, but I want to try and see if I can catch it here at the high ISO. Alright, well, I don't see it, but I'm going to have faith in the telescope, so let's drop it down. Let's go down to 32,000 and stop it here. And it'll give me back my exposure. Probably not because I did that. Okay. Now let's go up to let's say, let's do 25 seconds just to grab it. Make sure it's there. I think we should be able to see it. The telescope looks like it's, well, the guiding scope might not be in view, but we'll make it work. We'll figure something out. I just want to see the Crab Nebula again. Did you guys get to see my the Crab Nebula that I shot the other night? I ended up stacking a bunch of them, and man, it was just stunning. You could see these wonderful filaments. Well, that ain't it.
But what you're just referring to, that's up on YouTube, right?
It's actually, yes, but it's also Facebook, on SkyTour LiveStream on Facebook. Oh, cool. It's up there. Okay, the Crab Nebula is not in this image. Again, the guider is having trouble because it can't acquire. It's at an angle that's preventing it from acquiring, which is not good, you know.
No, it's not good at all.
No.
Keep calm, carry on.
Yes. Sadly, we lost Terry Jones from Monty Python.
Yeah.
All right, let's try going.
What a legacy. Okay.
I know, huh? Very amazing man. All right. We'll come back to the crab, maybe. Okay, we're lining up now. On what star? Okay, we're going to line up on Propus. And then we should just have no problem going here. I think that the auto guider could not align on a star. That's why it didn't get to the crab.
Too faint, perhaps?
No, not at all. Actually, it's not that it was too faint at all. It's just that it was actually there's something blocking it. Probably part of the dome.
Joan S. says, this is a great escape from the stress of the world. She feels like she owes you a cover charge or something. Yeah, copy that, Joan.
Well, you know what? It's wonderful. If people want to donate, they certainly can. And I'm certainly not saying that just because you said that, Joan. But we do appreciate all of you anyway, no matter what. All right. We should have acquired. So I'm going to take the picture.
Donald Kunzer is asking if that was a section of Cygnus a minute ago.
No. Cygnus is a summer constellation, Don. So,
okay.
Yeah. I can see that the telescope actually, it looks like the guide system is being blocked, but we're going to find out. We should be able to, I don't see, I should be able to see the cluster, and I don't see it, so I'm wondering if maybe, let's go see. Yeah, it's sort of, it is up here, but I'm not happy with that. Don't worry, we shall figure this all out. I'm picking objects that are too high. Again, it's the dome.
Yeah, damn dome.
I love my dome, but the dome is causing a problem, because when it's up like this, I gotta show you, because I want you to understand what's happening here. The guide scope is on the other side of the telescope, okay? It's on the far side of the telescope, around at about this position, actually about this position. And it's probably, it's got two scopes. One's at the end, this end, that is sticking up even further. And then there's a main one that's sticking down below it. And that upper one, if it gets lost, or this piece of the dome gets in the way, then we're not going to be able to acquire. And I think that's what happens, because normally I have absolutely no trouble getting to objects with the telescope. So, and I don't know why it's doing that, but it is. Let me see something here. I'm going to try going.
Meanwhile, Marianne Robb's saying good night and thank you much. Let's see. I don't want to paraphrase. What did she actually say? Oh, can I get it back? Nope, it's your screen. Okay, anyway, good night, Marianne. Take care.
Oh, okay. Thank you, Marianne, for coming. I really enjoyed having you here. And we will carry on as always. I'm going to go see. This is, I believe, where we're supposed to be. Let me just bring this up. Okay, now if I were to let it acquire here, hopefully it'll acquire. It couldn't steer here because it didn't have the acquisition. Yeah, again, I need to have the roof off. But if there's good news, it is that we're pouring the foundation next month, and after that, the building is going to be built by a shed making company as a kit, and then we're going to transport it out to the desert, and the folks I have out there helping me are going to build it.
Wow.
And then we're going to get the roll-off system in place, which is very simple because it's going to be a garage door opener. And it's going to open.
That just blows my mind.
Well, they open garages. Why can't they open roofs?
Yeah, why not?
It's going to be a steel roof, too, meaning it's going to be a lightweight steel because there's fire danger at times out there.
Sure.
And so embers falling on the roof will do nothing.
Yeah. Oh, that's great. Great planning.
And then on a post outside the observatory, not related to the roof, will be a all-sky cam, which will allow everyone, including myself, to see the weather before we actually choose a night of astronomy.
This is so ideal.
Yeah, it'll be great. Okay, there's the cluster I was looking for. Okay, this is Measure 35. It's in Gemini, and there's another cluster over here, and I'm going to move it back and take a picture of that to show you, because I like to talk about that cluster. It's really cool. So I bring Gemini over there. I'm going to raise it up a little higher and center this bad boy. So this is the little guy now that I'm centering, and let it acquire. I think we should be okay. Now, that cluster that we saw is one that is amazing because the big one was Measure 35. It has another name. It's called the shoe buckle cluster. It's at the end of Gemini. If we go into our planetarium system and we look and we actually zoom out a little bit, okay, we're looking here, all right? And if we look at what the mythology looks like, we have two twins standing next to each other, and one of the shoes, okay, of the twins has a buckle on it, and right at the top
I was gonna make that guess. Is it Castor or Pollux?
That is Castor that we're talking about, okay?
Okay.
Yeah. All right, so now we come back, and we go look at what we saw, what we got. Now you see the shoe buckle cluster on Castor's shoe, and to the right is a smaller cluster of stars that aren't nearly as bright, and some of them look redder. This cluster and this cluster are probably close to the same age. So why would we see what appears to be older stars, redder stars in here? The reason has to do with the music.
Yes,
No.
I was going to say that's just so perfect.
The music has to do with the fact. The reason has to do with the fact that this cluster is actually quite a bit more distant than this cluster, and
yeah, that's how it appears to my untrained eye. That there's a perspective difference. Yeah.
Yeah, and when we look at, let me see if we actually have distances for this one. I don't know if we do, but we're gonna find out. All right, so we've got that cluster there, and then we have 2158. Okay, now the cluster here, the shoe buckle cluster itself in Gemini, let's see if this one gives us a distance. Doesn't give us a distance, but it's actually quite a bit further than this cluster in Gemini. And let me see if I can get this cluster in Gemini to select it. So, okay, there we go. Its distance, if you see here, it says it's 2,772.7 light years. Okay, and this little one here, is a lot further.
Aha.
So it is red not because it has older stars. Again, it's about the same age as this. So why do these stars appear redder? You can tell that these are bluer and these are kind of a yellowy, more redder. The reason is due to something called interstellar extinction. What's that? Well, it's the same process. It's the same process that makes the sun red at sunset. Okay?
Oh.
In between us and this cluster is dust and gas. And as the light from these distant stars passes through it, some of the blue light gets scattered away. Okay? And that blue light that gets scattered away doesn't make it to our eye. Only the red, orange, and yellow and green part of the spectrum actually gets to our eye. And that's why the stars look redder. I had to calculate extinction all the time when I was working in photometry, which is the programmatical way of actually getting star data and deciding how bright they were. You had to calculate all kinds of extinction. You had to calculate interstellar extinction from distance. You had to calculate extinction due to our atmosphere. Okay. And then you had to calculate how much turbulence the light was being subjected to because of our atmosphere. So, I mean, there's a lot to actually doing the real science with this, But anyway, this is M35, the Gemini cluster. And then this is little NGC 2158. It was always there, and I never saw it as a kid because I had no idea it was there.
Wow.
Because I just didn't know,
Yeah.
Everybody looks at M35, They always look at M35. But, that's the way it is. Now, let's see.
Wow.
Yes. So let's now... What's that? Were you saying something?
What, me? No, I was, I'm sorry it was so loud. I was chuckling inwardly at this whole thing. It is just mind-blowing. I mean, we kind of, in a sense, as much as we appreciate what's going on right now and what you're doing, it's sort of like, well, we take it for granted. Yes, there's Mark Antonian. But I mean, see, here's the other thing. You present this with such awe and wonder that it's breathtaking. I mean, it isn't just, it's not dry science. It's just, you make it alive. So that made me laugh.
Okay. I'm glad. Thank you. That's very kind. I don't believe in science being dry. I just don't. I think that it can be exciting. And you know what else? It's for everybody. And people sometimes stay away from it because they think they can't understand it. Well, guess what? What if you could? What if you could learn about all these really cool things that are in the universe? What if you could understand what was going on? What if you could understand how a black hole actually functions? Okay, what if you could? So that's something that I think is domes in a way. That's something that I think is worth looking into.
Yes,
it really is. Yep. Okay. I'm gonna have to go out and move the dome.
Oh no, not again. All right, well, I'll just read through chat.
Okay, I'll be right back.
All right, we'll be right here.
Of course.
Carolina. Oh, I'm sorry, Mark. Did you want to say something else?
Oh. No, go ahead. I'll be back.
Oh, okay. Okay. Stay warm. Carolina Sky. So, my gosh, you teach guitar students. That is so cool. I wish you were here. Yeah. Well. Wow. It's so interesting, that connection between music and science. So many people have that. I don't know, some people say that music is basically math. There's somebody in my family who is a plasma physicist who writes concertos. Okay. In fact, he works at Lawrence Livermore. But I mean, it's, so that's an interesting thing. So very cool. And, Daniel Whitaker, you blew up a mercury vacuum pump one time. I cannot imagine. I wish I could ask you what that was like. I bet it went blammo or something like that. Yeah. So, David Schmidt, you live where you can't see stars. and that is a bummer. But I understand because I'm in the Los Angeles basin, and now a funny thing has happened over the last, I would say, decade. I'm in the eastern end of the Los Angeles basin, and a city called Claremont, and we somehow are able to see more stars. I don't know. It doesn't seem. I'm not really sure what the science is behind that. But yeah, it was like, whoa, am I in the country? No, I'm in my backyard and I'm seeing all these, I will just call them stars out of ignorance. But Donald Kunzer says, see you on the dark side of the moon. Right, that Pink Floyd discussion. Absolutely excellent. Carolina Sky, the guitarist from Queen, Brian May was that's right, Brian May. In fact, when I was doing my news gig back at Inception Radio Network, I did 30 minutes of news every day, and I would, as it's called, farm the sites for information. And I remember running across something specific, but I can't remember what it was now. To which something really significant, and Brian May had made quite a contribution. So that's an interesting thing. But there we go again with the science and the music. Yeah, what an amazing thing. So there's nothing wrong with silence. I don't have to keep talking. We can just be silent and wait for Mark. David Schmidt says there was a video when they talked about the comet. Oh, yeah. The comet named after Freddie Mercury. Right, yeah. Maybe that's what I'm referring to in my Brian May memory. Yeah. Wow. And that's just, when those disciplines, as one calls them, align, some good stuff can happen. Some amazing stuff. I don't know. We tend to have that terrible stereotype of rock musicians as being, ignorant, blah, 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 blah. But then here I'm coming to Tom DeLonge. Yeah, I can remember back when I wasn't sure how his last name was pronounced. Was it Tom DeLonge, Tom DeLonge? And this was right before To the Stars Academy of Arts and Sciences was born. Daniel Whitaker says, music, rhythm and music is one of the few things we never see in any other creature. Wow, unique to humans. Wow, and that's quite amazing. I'd never thought about that. Occasionally there'll be, some kitten video on YouTube of a cat doing something to what we think is music. But I don't know how much editing goes on. Did anybody else see the video? And you can't answer me, so this is a spacious ask. But there's an incredible video of somebody pouring a bottle of water into a bowl. And you can see there's maybe they're holding the bottle over the bowl, which is about, they're holding it maybe 2 feet over the bowl. And around this bowl are 2 parrots that are dancing around that bowl. I don't think it's CG. So my brain goes to what do parents do? Parents. What do parrots do in the wild that is represented by that water? Is it a waterfall kind of thing? David Schmidt says that all members of Queen had degrees. Wow. I love that. I love that. And Cleopatra says music is a passion, as is the wonder of the stars. They just go together perfectly. Wow, Cleopatra, do you right? Yeah, that is beautiful. I like that a lot. It catches the imagination. So, yeah, Water of the Skies, Genesis, Water of the Skies. Oh, I think that's a piece of music that I'm looking at. I'm sort of reading every other line. Daniel Whitaker says to Genghis Khan, we hear the music in things like whale song or bird song, but to them it's just communication, not music. Yeah. Donald Kunzer says great space songs. Absolutely. Yeah, mockingbirds. Somewhere there is an anecdote. I think, YouTube. I don't know if there's footage or audio. That apparently there are mockingbirds in Los Angeles who mimic car alarms. Yeah, I don't know what to say about that. They're built in. They're wired for that mimicry. But my brain sort of went wow, what about the future? In the future, let's just say some sci-fi trope. We have mockingbirds who make all kinds of sounds. And of course, the people who are living around them have no idea. But it is significant. Here's something significant. He's back.
Ha, you're funny.
That's great. Hello, how did it go?
Oh, it went okay. I was actually, I noticed, among other things, that we have a lot of clouds out there right now, but we do have a significant opportunity to try to image one more thing here. This is called the Rosette Nebula. And I'll give you an idea what the Rosette looks like. Because we have we've actually taken images of the Rosette in the last few days that are just beautiful. And they're, we're doing certain things. We're trying to do certain things with the Rosette. Okay, give you an idea. Okay, I'll give you an idea of what we actually took a picture of here. Okay, so this is the Rosette that we filmed. Okay, that we took pictures of. You can see this beautiful cluster, and that beautiful cluster is actually what we see when we look at this. Let me do it this way. When we look at this, let me take that down. Okay, when we come through here, just a sec. All right, just like this. So let's do this. Okay, this cluster, and I'll get rid of me for now. You don't need to see me here.
Well, we can bear up.
All right, this is the cluster that's in the middle of this. See? Okay, so what's hiding in there, all right, in that beautiful location, what's hiding in there among these stars is this beautiful nebula that's here that you just cannot see. All right, so if we were to go, let's say, up to 51,200, which is really high, and do a 30-second shot, okay, you'll see a little bit about the raw imagery that we'll get. All right, so, and it's nice because I'm using the same telescope. I can actually do these kind of comparisons. Say, okay, this is what's hiding back there. Okay, so now we're going to go show you this. See, so those two stars are these two stars here. See.
Yeah.
Right? Yeah. And you can see how much the images bloat because of the fact that they're bright. Yeah. So now we'll take a look. So now this is what you see, and you go like, wait a minute, that does not look like this right here. That is correct. It doesn't. So what you do is take many of these, and then you can actually then stack them. You can actually see, if you're careful, you can actually see some of this nebulous detail here and here. All right, and those dark lanes that we saw before. Okay, well, where are those? Well, there's one here, there's one there, and there's one there, right? That's on the picture.
Right.
Now, what about on the actual photo? Well, on the actual photo, all right, we actually have, you can see the dark lanes just barely. See? Yeah. So when we take these pictures, what this does, you can actually see the pink area, right? And a little processing maybe helps a little, instant process. So you can see this works out. You can kind of see how that image can come. So what we do is we add a bunch of these together. And when we add a bunch of these together, we end up seeing, this image down here. That's what comes out of it. And that's actually just the beginning. And this is in an area of Connecticut that's actually got some light pollution. We get out of that, and we will have a very, very, very different experience, all of us. In fact, I'm thinking that if the first light in Arizona of SkyTour LiveStream has anything less than 5 million people watching at the same time, okay, I'm just kidding. I mean, if we can get like 400 or 500 to watch on the inaugural view, then I have a feeling that that'll be great. Oh, I just actually want to announce also that I will be in Laughlin, Nevada on February 14th through the 22nd. I'm speaking at the Mega UFO conference there. And On the 23rd, I'm heading to Arizona to work on the observatory, like I told you before. Also, if you haven't yet thought about it, maybe you might want to consider buying the book, The Populated Universe. It's on Amazon, and I made it in 3 different formats. You can buy an ebook. You can buy a 6x9 black and white interior of book, or you can buy the full color big 8x10, which has all the color photos in it. It's not a book about astronomy. Well, it is, but it's a book about exoplanets and extraterrestrial life. All right, and it's over 300 pages, so it's not a lightweight, but it's not a heavyweight either. I don't use big concepts that we're going to leave in the dust. I wrote this the same way I deliver SkyTour LiveStream. So you hear it in language that you understand, and those that are into science and know all this stuff, you'll still enjoy it, I think, because I write it for you too. So
yeah, how did you do that? How were you able to blend that? I don't know. I mean, I've read it, and it's sort of like, oh, not only is it how you present, but it's also how you present your humor. There are many really, laughing out loud moments, and that's extraordinary.
Well, I appreciate that. Thank you. It comes down to a few things. I actually think that, being one of these science-minded guys, I have had trouble understanding concepts throughout my educational experience. And I examined why I was having trouble with that. And I think that's why after I got my astronomy degree, I actually worked teaching gifted children for several years. Only 3, and then I ended up moving on to computer science and going into a master's program for computer science and doing the whole IT thing for a big company. Realized it's not my thing, So I left in 2001 and I started my own company, FX Models, which is a model making company that does a lot of work for the Navy. I got a 10-foot model in the shop right now I'm working on. So I spent all day working on that big submarine model. And then came in here at night to unwind and do this with you.
Which is kind of hilarious when you think about it, from under the water to up into the cosmos. Wow.
Oh, yeah. Well, see, that's the whole thing, right? Inner space and outer space. The middle where we live, not so much. It's kind of funny.
Yeah. Leave it to the others, hey.
Yeah. Well, Tara, you said something. It's like having a conversation. I write in a conversational manner, and you know what? I was criticized for that all through school because I was writing in a way to draw people in and say, listen, I'm right here with you. Let's talk, And I write in a conversational manner, and I literally got such negative grades in high school. I remember that. I had English teachers tell me, "Oh, this is no good. You're writing. You're too conversational.
This is not the form, right?"
Yeah, conversational. I said, but don't we converse with people? I mean, we conversate, okay, with people.
Word.
So I think I'm going to continue being conversational, if you don't mind.
I just have to toss in. We are so glad you did. Remain conversational.
I hope so, because I think that's really it's really the right way to go, because it's why people can understand when I'm trying to share stuff. It's why people do understand it, is because it's conversational. It's not threatening. It's not language that's gonna make people have a agita,
Yeah, you absolutely remove the entire intimidation factor.
Sure, there's no intimidation.
Yeah, no.
There's no stupid question. There's no intimidation. I mean, it's just what it is. It's what it all is about. And that's, I think, probably the best possible blend,
Absolutely.
Yeah, so that's why I do that. I think that's why people like when I speak. I mean, I have speaking engagements all over the world, and I do it because I like it, you know.
Well, it likes you.
Well, okay, that's
quite
fine.
obviously.
That's kind of a funny way to say it, but yeah, I guess.
Turn it on you, yeah. Carolina Sky Astronomy says that this is my favorite live stream on YouTube.
Oh, well, that's so nice, man. Thank you. That's so nice. Thank you for saying that.
He also says you're awesome. Or she. I don't know.
Well, I don't know either. And it's not important. You know? We are gender free here. You know?
Yeah, exactly. Yeah, and D. Smith says you converse in a way that our up and coming astronomers can understand without making it so intimidating. There's that word again.
Yeah, I don't think intimidation is just not the way to go.
No, it kills the spirit.
Oh yes, it does. Yeah, I agree with you. So I guess in that way, you know, we'll have plenty to talk about for many years to come. And
Carolina Sky is a he, by the way.
Okay, I see
just
that now.
Tossing it in, yeah, okay.
Well, yeah, I say that because he says gender free.
Yeah.
Right. Well,
John, hey John.
I don't have. It's Jim from North Carolina.
Oh, Jim. I'm sorry. Hello, Jim.
Still a male name.
Yeah. Okay. Yeah. My gosh. All right.
Okay.
Okay.
Yeah, but still, it's actually pretty funny. You know, we actually have a lot of people that are just so I guess they have such rapt attention in astronomy, and I just love it. I think people are really fascinated by this entire world.
Does it surprise you?
In a way, it does, because I never really expected that people would be so, I guess, into astronomy.
Yeah.
You know?
Yeah.
I just never expected it.
Well, you trigger that. No, you do.
Maybe, I guess.
Yeah. Joan F. says, humbleness is such an attractive quality in a human being. Yeah.
Well, I guess, you know, when you come from a place where, you know, a lot of people are, they say, "Wow, look at me," you know.
Yeah.
You know.
Oh yeah. Oh gosh, it's kind of the generation of "look at me." Mm-hmm.
Yeah.
Yeah.
Oh, rock star crossing the line. Yeah. Joan, is it good to know? I'm not
well,
so
at least
sure.
we're now aware. Okay.
Yeah. Yeah, that's okay. I know that.
And Daniel Whitaker here. This is poetic from Daniel. In one sense, we're on a spaceship whizzing through the universe. It only makes sense to look out the window since we're along for the ride. We're not driving.
That's right.
I like that.
Yep. That is exactly right. Yep. Yep. Well, I'm noticing that outside anyway that we have clouds. We've been doing 2 hours 14 minutes so far. So I'm afraid to say that I'm gonna have to close the dome here because I cannot let that scope get any kind of weather on it whatsoever. I gotta let it stay pretty reliably dry, and we do have weather coming, so I'm gonna have to do it. I'm gonna have to just close down for the night. Don't want to.
Shut it down. Shut it all down now.
Yeah, it's like, Scotty, we've got to shut it down now, or else we'll die. I said, I'll shut it down now for you, sir. Exactly. So, in any case, I do want to thank all of you for coming out tonight and having a great time. I had a good time with you all here. And I will, before we go, I'll just kind of take you back to some of these photos. There's a few that a few additional ones that I might have here that I want to show you. This is a really cool one. This one is, we're familiar with the Trifid Nebula. In summertime, the Trifid Nebula has these 3 dark lanes in it, so it's a tri-fid, tri-shaped nebula. Well, this is one that's up north. This is called the Northern Trifid, and you can see it has these dark lanes in it as well. It'd go missing. You'd never notice it in the night sky. All right, but there it is. Here it is, in all its glory, the Trifid Nebula.
Beautiful.
Yeah, the Northern Trifid, and it's actually a stellar nursery as well, and it's beautiful. There's a lot of young stars in there, hidden behind the dark dust. Just like, I think, was it Donald that asked that question earlier about, how many more stars are hiding behind the nebula?
Wow.
Well, a lot. You're absolutely right. Then another one that we took pictures of the other night is this one. This is the Cone Nebula. Okay, you can see the Cone Nebula. It's called that because of that shape you see. Wow. And it has these two tiny little stars right there that are helping to power it up. It's really amazing. And the cone is extensive. It goes throughout a lot of this. I can't wait to image this in Arizona. We're going to see this like never before.
Wow.
I may not shut the building ever. I might just...
Yeah.
The Day of the Triffids, that's right.
Oh, yeah. Oh, my God.
Remember those things? They sound like this.
That's it. Right before they shot that, whatever it was.
Yeah, and they'd make you blind. Remember? They'd make you blind.
Yeah, that's right. That's right.
Yeah.
Yeah, I kind of know something about that movie, those shots, all the shots about the biologist couple in the lighthouse, and finding out that those were all added after the movie wrapped. Production felt, well, this just, we're not doing enough here and blah, 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 and so they put those in. I actually worked with Howard Keel, who was in that movie.
Wow.
And so, yeah, that was the trick, was that nobody knew. It was so well done.
Wow. Yeah, very cool. This is the horsehead, by the way. This is right to the left of Alnatok. Alnatok is up here, up above. This is Sigma Orionis. This is an artifact, a reflection from a brighter
that
star.
was my question. Okay, so that's an artifact. That diagonal line there.
Yep.
Okay.
This is Sigma Orionis. It's actually the star that's powering this nebula right here. It's causing this nebula to glow, and it's light years away from it. So you see, the radiation is extremely powerful from these stars.
Yeah.
And then, in the same way, this is the hydrogen emission that's silhouetting this darker dust that's sticking out in front of it. Here's one that is not hydrogen emission. It's actually that scattering light again, a reflection nebula. And so the star is not hot enough to ionize gas in this region, or there's no gas in this region perhaps. Very little. I mean, there is a little bit of a pink glow here, so it's doing some ionization, as you can see. Mm-hmm. But it's not doing a lot. So this is buried in the dark nebula, the dark dust, but it illuminates this dark dust, and the dark dust scatters some of the light back out to us. So that's it. This, again... is the Horsehead Nebula, and it's really beautiful, So I just think that, and again, these are all SkyTour LiveStream. We're not, we're certainly not doing anything that's somebody else's stuff. I mean, we're only, this is only stuff here,
Exclusive.
Yeah.
Yeah.
Yeah, and I'll show you. This is another one of the rosettes that we did. Remember, I showed you the rosette a little while ago. We actually imaged it. Well, here's the rosette.
Oh my God! And that is why it is called the rosette.
That's right. And I showed you. I took a picture of this part of it with this telescope. That's the field of view of the scope, right there. Okay, but this is the whole thing, and I shot this in wide angle using our 5-inch refractor mounted on the main scope. And did this shot to just give you an idea of what we're actually seeing. So that's the whole rosette that you see right there.
Just gorgeous.
Oh, it's beautiful. It is beautiful. And again, if you look at the raw files, okay, this is the stacked result. This is after stacking, all right? And then, of course, this is after doing the image processing, okay?
Wow.
All right, but for the raw files, this is the raw file. This is what was taken. Okay, that's what it looked like after each exposure.
Yeah.
Yeah. So then we ended up being able to get us down to this right here. Beautiful.
Just astonishing.
Yeah, it's really pretty, and I like that. And then we actually did more wide-angle shots at night. We did the Running Man with the Orion Nebula. What's Running Man? Well, it's this nebula right up here above the Orion Nebula, which is right here. See, we've been zooming in on the Orion Nebula, seeing about this much of it tonight. Well, this is above it, and the Sword of Orion, the Belt of Orion, is up above all this. This is the Sword of Orion. This and that little cluster right there. These three things make the Sword of Orion. And this is the Running Man Nebula, so named because of the appearance of a running guy right here.
Yeah.
I don't necessarily see that, but okay.
Yeah, it's a stretch.
Yeah. But this is the nebula, and it's really cool. And the other thing is, these shots are available on SkyTour LiveStream on Facebook. You can actually go grab these and use them however you like, because I upload everything at the highest resolution so that you guys can use them for wallpaper, whatever. No charge, no nothing.
Which is incredible.
Yeah, and I don't put, SkyTour LiveStream on there. I don't put copyright stuff on there. How do you copyright a nebula,
Yeah. Listen, I'm sure there is some intellectual property rights lawyer who is working on that right now.
Yeah, I agree.
Yeah.
All right, and then we saw the Horsehead, but right near the Horsehead is another nebula. And it's actually to the left of Alnitak, and you'll see Alnitak above center in this picture. Okay, and here is Alnitak, and here's the Horsehead, and here's Sigma Orionis, which is illuminating this nebula. And here is next to Alnitak, this is called the Flame Nebula. All right, so we have the Flame, we have Alnitak, and we have the Horsehead all in one view. And we have an interloper. This is a satellite that actually wandered through the view.
Oh, really?
Yeah.
Oh, yeah, I see.
And I took several 20-second shots here, and you can see, this sounds like Mr. Rogers' Neighborhood now.
No, hey, but listen, that's great.
Won't you be my stellar neighbor? Sure.
Yeah, truly. Do you have the sweater that Mr. Rogers wore?
He zips it all the way up and then unzips it a little.
There we go.
Yeah.
Sometimes a shoe change. Involved.
Yeah, right.
Oh.
Yeah.
Bobby Burgess is in the house. Hello, Bobby.
Hey, Bobby. Thanks for coming by. So this is Alnitak. It's the leftmost star in the Belt of Orion. And right next to it is this amazing complex. It's just beautiful. Okay. So I'm glad that I got a chance to show you that, because that was really cool. And now we have one last one to show. This is the Christmas tree cluster, right? And the cave, which we looked at earlier. This is again wide angle, and you can see that the satellite was going through. And these are where I stopped the exposure and then started it again. You can see that I took this one, and then I waited a little while because I wanted to get the satellite to keep going before it interfered with this. Right. I didn't want it to interfere with this again. So, yep. So, that's that. Now, we also, you can barely see down here. You can barely see, I'm trying to see where it is, actually. Yeah. I'm trying to see where the cave is in here. Maybe if I zoom in a little. Yeah, it's right here, but you can barely see it because it's being overwhelmed by the brightness of everything else. But you can see there's a lot of nebulous detail, and of course, many, many stars.
Why is it called the cave, Mark?
It's not. It's called the cone. I'm sorry.
Oh, the cone. Oh, okay.
Yeah.
I see. So
my mistake.
And it's that cone shape.
The cone is that. Yeah, I mistake. The cave's a different nebula. I apologize, guys.
Okay.
But this is the Christmas tree cluster, because it looks like an upside-down Christmas tree. With the cone being the angel on the top.
Right.
Yeah,
okay.
So this is
so
the
it's
stump.
inverted. Yeah.
Yeah, it's inverted. Actually, let me not invert it. Let's move it the other. Oops, sorry. Let's move it the other way. There we go. No, I don't want that.
No, that's the same.
Let me get rid of that. Okay, so let's see. There we are. So there's your Christmas tree right there. Topped with a cone.
Yeah, right.
I guess it's a pine cone. I don't know.
Oh, that's perfect. Well, of course it is. Yes.
I don't know.
Well,
so yeah. For me. So there you go. And so anyway, unfortunately, like I said, the clouds have moved in to make it hard for us to see anything else tonight. So I apologize, guys, but I want to thank you for coming along and hanging here with Carl, and myself for the duration. I will be back on the next clear night, and maybe so will all of you. If you guys like this, please do hit the thumbs up, and please do pass it on to all your friends. Talk about it on Facebook, if you will. Also, go to Amazon if you want to buy the book, The Populated Universe. It's really a wonderful book that actually, it took me quite a while to write it because I really wanted to get it all right, it's done and in print, but I still have a forward to do. A forward's getting done for it by Douglas Trumbull, who of course is the Academy Award winner, did Close Encounters of the Third Kind, Blade Runner, worked with Spielberg and all of those people, and we're very good friends, and he's worked with me a lot, and I've worked with him. He sent me a bunch of messages yesterday because we're working on that Tesla movie, and he goes, look, I made a copper atom. I got these really cool shots. What do you think? And I wrote back, well, that's beautiful, but now that you got me going down this path, I have another idea. And he said that he loves the idea, he wants to do it, and he's like getting anxious to do it. So he's waiting for the next installment of the payment to come from the client, so we can start to indulge in our mutual desire to create the microscopic world, the quantum world. It's really cool, If you ever a chance to ever listen to Doug Trumbull speak, I encourage you to do that. And if you tell him that you know me, he'll have you arrested. No, he won't. Some of you were waiting for that. No.
Yeah, I like
if you tell him you know me, he'll probably spend time talking to you. Okay, because he's really the most down-to-earth human being on planet Earth. When I first worked for the guy, I found myself actually in the position where I was on the set working on a commercial for Burger King. I had no idea about Doug. I hadn't met him but once, and I worked for I thought it was going to be a couple days on this commercial to do one particular task. But by the end of 2 weeks, I had done with him 13 or 14 different what we call setups, visual effects shots. And he never talked to me once. He was on the set once in a while, then he was gone working with other people, and I never thought he noticed anything I was doing. So I thought, wow, I can always just put this on my resume. I worked with Douglas Trumbull. Wow, Academy Award winner, ooh, ah. And I figured that'll be that. Well, then it turns out that as we wrapped, the last shot that we did, coincidentally, was a shot that I created that we had to do. And it was a shot where it involved a giant Oreo cookie.
Right. And that wasn't the double stuffed, right?
It wasn't.
Okay.
It was a giant Oreo cookie, and this giant Oreo cookie was going to spin at 2,400 revolutions per minute. It was very, very going to move very, very fast. And so I created a rig to make it spin very fast. And oh, by the way, it also had to have liquid nitrogen pouring out of it.
Oh, by the way.
And the liquid nitrogen had to, be blown behind it with a wind source at the front. And we're going to film that at 1,200 frames per second and turn it into a slow motion cookie comet.
Wow.
Yeah. See, so we actually we did it, and then when it was shot, it was a wrap and everything was done. It was the last shot of the commercial, And I was just packing up my stuff, putting things away. And there were like 50 people on the set, that were working on this commercial.
Right.
And Doug says, "Can I have everybody's attention, please?" And of course, I turn around dutifully, like I should, because he's talking. And of course, who ignores him? Nobody. At your own peril, you ignore him because he'll say something you probably should have heard. And then he does something that I've never seen someone in his position do. Something that shows what kind of person he is. He has every right to be an arrogant son of a gun. He was the CEO of IMAX. He told Stanley Kubrick where to go. He told Steven Spielberg how to do things when Steven wanted to do things a certain way. Ang Lee has been up there a number of times. Jim Cameron, all these guys, big guys.
Right.
Well, in any case, he stopped everybody and said, "Before we all go, I just have to make an announcement." And so I thought, oh, okay, well, he wanted to see if we all can work together and we're going to go on to another commercial maybe or something. And he says, "I just want to take a moment to recognize Mark D'Antonio." I went, "Well, what?"
Oh, my.
And I'm shrinking because I don't like that attention. And he's like, come here. And I go over there and he goes, "He was put through the ringer for the last week and a half here. We had just met. He was trying to get over his fear of meeting the god, And of course everybody laughs because he's so self-deprecating. He goes, "I know, I'm a god," he goes, and he rolls his eyes. he bristles when you tell him he's like phenomenal. He's like me. He doesn't like to get the attention.
Yeah, I got it. Humility.
Yeah, he's very humble. So, and then he says, "I just want to publicly say that you perform very well under fire." From the people that were trying to tell you what to do, and sometimes it was coming from many directions. He goes, "We're happy with how you did it, and I just want to recognize you." And he starts clapping, and I'm sitting there all embarrassed, and of course everybody follows suit. And I didn't think that I performed so well, especially since my first day on the job, I nearly destroyed his garage door. We were making catapults to catapult these cookies, to make a special shot where all three of these cookies from three different directions all show up in the center of the camera frame and blow up. Well, I had to make the cookies that blow up, and I also had to help make these catapults that would launch them. And the catapults were not strong enough, so I ended up telling Doug, "Oh, Doug, you got surgical tubing here." It's Mr. Trumbull back then. It was Mr. Trumbull? I see surgical tubing roll on the floor. Why don't we use that? "All right, have at it." So I did. And his son said to me, "And I don't know, it looks like too much surgical tubing." And I went, "No, I think that's fine. Mr. Big Shot here, right? Mr. Trumbull loved my idea," I said to myself. So I thought, hey, I'm a big guy on campus now, So now I'll show you what to do there, boy. So I put the wooden puck that served as a stand-in cookie on top of the catapult, and we launched it. It went so fast that it was like a bullet. And it blew a freaking hole in his garage door. And I could not believe what had just happened. I said, in my head, I'm thinking, "Oh, I'm so fired."
Yeah, right.
And his son looks at me and says, "You're so fired." Without him even saying it. So I hear Doug out in the driveway, of course, seeing his insulated garage door now, blowing apart.
And so, is there a dent in the door?
Oh, yeah. Okay, and he heard it and he saw it from the outside. It made a crack and stuff was coming out, the styrofoam. And he comes running in and he starts saying all these naughty words and says, "Who the hell, blah, 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 blah." And I go to raise my hand and say, "Yeah, it was me." And I turn to my left and his son's already pointing at me with that smirk on his face. He did it, Dad. And I'm like, "Yeah, I did it." And he goes, "Wow," he says, "well, you're on the right track. I'm liking it, but just be more gentle on my garage." I went, "Yes, sir." And he walks out, and I'm like, "I'm so not fired." And for the last 7 years, we've been very good friends, and we just went to Niagara Falls to film part of the Tesla movie. We were deep underneath in a hydroelectric dam filming these high-speed turbine shafts at inches from them and doing it all in 3D.
Wow.
What a fascinating movie. And then we have a Tesla coil on the set. It's an 8-foot tall Tesla coil, And wait till you see the sparks that can fly. I shouldn't say sparks, lightning that comes out of that. Imagine.
Really?
Oh, yeah, they generate lightning. And they're very loud, okay, because that's thunder at the scale of a Tesla coil. Yeah, unbelievable. So, you know, and of course, me, you know, I'm always like, it's always that moment you go, should I do this or should I not do this? You know, and then you do it and you regret it instantly. We had a smaller Tesla coil, about 24 inches tall, they were using as a stand-in to make some of the electrical arcs that we needed. So when I saw this thing arcing, and I thought, well, that doesn't look like it's too painful. So I just stuck my finger in, and this blue arc, the last thing I remember is this blue arc jumping right to my hand, and it felt like I was being snapped with an elastic that was bigger than any I've ever seen before, and there was pain and burning, and it was so painful, and my hand was numb, and I couldn't close my fingers for a while, and I look at Doug, and he's looking at me like, what are you, an idiot? And I'm like, yeah, I'm an idiot. You know? And so
what
anyway,
were you thinking? What was do you remember your conscious thought before you actually touched it?
That's the fact.
Before it touched you.
I was curious.
I
was being a pioneer. I wanted to see what it felt like. You know? Yeah. I'd be happy I don't do that with things like bombs and stuff like that. I'm not a guy like that, you know?
That's good news.
Yeah, no, I don't do that. Although I did make hydrogen balloons as a kid and detonate them over my town, and that always brought the police, so I stopped doing that.
So that's the bad boy aspect of it.
Oh, yeah, I enjoyed that. I couldn't stop making hydrogen. It was great. I figured out how to do it from the library. I mean, I was 12.
Oh, my God.
No, I was 12. Yeah.
So how big were the balloons? What was the size of the explosion?
The size of one of those cleaning bags that you get from your dry cleaner.
Really?
Oh, yeah, I'd fill those with hydrogen that I would make from my little still in the backyard. It'd run 24 hours a day. It got so hot you couldn't touch the glass jar that was fomenting, and it was actually an old water cooler bottle that was made of glass. And
so you weren't making moonshine, you were making hydrogen.
I was making hydrogen, yeah. I grabbed metal shavings from the metal shop next door to the house, a little tiny mom and pop shop there. And I would go into the house. Mom, do you have any Drano? Yes, under the sink. What do you need that for? Oh, I'm doing an experiment. Okay, well, don't use it all. Well, I did.
Oh, God, what a mother. That's great.
I poured the entire bottle of... And Drano, see, is sodium hydroxide. And I read in the library that sodium hydroxide will eat metals and will give off a precipitate of this other gas, stuff, and corrosive. And then it'll liberate hydrogen from the OH group on the NaOH, the sodium hydroxide.
Okay.
Yeah. So I said, I want that. Well, I created the hydrogen and it would come out, and I trapped the excess water in milk jugs. Ma, do you have any milk? Yeah, in the refrigerator. Glug, glug, glug. Pour it down the sink until the jar thing was empty. Wash it out. Oh, we're out of milk. What? I just got that gallon.
Hilarious.
Ma, do you have any cotton in the bathroom? So I took all the cotton and stuffed it in the milk jug, okay, and said, do you have any more? No. I said, no, there's not much left. Yeah, why? Because I used it all.
Yeah.
So then I stuffed it in the milk jug, and the milk jug was my water trap. It was going to collect the moisture coming out of the bottle because it was laden with moisture, and what was going into the bags, these clothing bags, water was dripping down the sides, and it was making them far less buoyant. I wanted absolutely dry hydrogen going into the thing. So one wasn't enough, so I had to make two, which means, Ma, do we have any milk? Yeah, I'll go get milk. Okay. I bought 2 gallons, sacrificed one to the sodium hydroxide gods, and put one in the refrigerator. And then when I finally got my dry hydrogen gas, filled the bags, and I would launch them. I must tell you, the first one I didn't want to launch, so I tethered it to the ground, and I said, I like the concept maybe of seeing this thing blow up. So what I did was I ended up taking a little toy bow and arrow set, dipping the end of the thing in gas, and lighting it on fire, and then going doom and launching it at my hydrogen balloon.
Wow.
Well, I did that 2 or 3 times with 2 or 3 arrows, and each time the arrows just bounced off and went into the empty lot next to my house, into the grass. And I was like, darn it all, it's not working. So I went and I sharpened the stick. I went and sharpened the stick on a little grinder, and then I came back out to do it again, and I realized the lot was on fire. Okay.
Oh, no.
And there's my hydrogen balloon in the middle of it, just tethered there. And I'm thinking, oh, no, I am not losing this hydrogen balloon. Never mind the fire. Okay. I went around stomping out the thing. I turned on the hose. Okay. And I'm spraying over my mother's fence into the empty lot, trying to put out the fire, which I did, but the whole lot was black.
Okay.
And I stomped it out with my feet. Meanwhile, the hydrogen balloon is still dutifully tethered there, screaming for the sky. So I decide I'm going to do this again, and this time, I know the arrow's not working. This little toy Cowboys and Indians bow and arrow thing just isn't doing it. So I just take a long branch, dip it in gasoline, and I said, I'm going to just burn through this plastic. All right, well, the long branch was only about 1.5 feet long. Well, how much longer could it be? Yeah, probably fine, right? It's just going to go foomp and be done, right?
No.
Yeah, okay. I thought. No. So I ended up holding the branch out, firing the end of the branch. Okay, it's burning. And I go and I touch the little plastic, and I just start to see the plastic melt. And that's where the lights went out, because next thing I know, I heard, and I'm now hitting the back of my head on the ground in the dirt.
Wow.
Okay.
Oh my God.
And I see this mushroom cloud of smoke going up into the air. And I'm like, wow, ow, wow, ow. I got up, and it rattled windows in the neighborhood. I'm telling you, it was probably about 50 feet from the nearest house. It rattled windows. It sounded like an M80 went off or more. So what did I do? I did the sensible thing. I ran into the backyard and stuck another bag on that thing because I wanted more.
Well, of course, that's the sensible thing.
Yeah. And then I said, it takes over 8 hours to fill one of these bags. So what I did was I cut them in half, made small pillows, and I filled each pillow in about half the time. Now we're talking, because I could launch one every 4 hours and blow it out of the sky. So...
It's just priceless.
Oh, I had so much fun. Let me tell you. And every time those things blew up, about 5 minutes later, you see the police driving down the road very slowly, looking.
Daughter, who's doing this right?
Clearly, someone called, and I just stood there by the fence. I waved, hi. They drove by, thinking nothing out of the ordinary. And meanwhile,
hi, I'm just a kid, right?
Meanwhile, I'm thinking, my balloon is almost full. I'm going to be launching this as soon as they're gone. Yeah. And then then I did that. I launched it, and I got really good at throwing sticks that were on fire at this thing. But there was one case where I actually lit my backyard on fire, and I had to try and keep my father from seeing it when he came home, and that was a big failure.
Yeah.
Yeah, abysmal failure. Because he walked into the backyard to go into the pool, surrounded by grass that was now black.
Yeah.
Yeah. So it was that's the kind of thing, though. That's my life, man. That's the kind of stuff that I did. I mean, I didn't really have too many friends. I was always sinking into books. I mean, I had a chemistry set that had real chemicals in it, okay? And I made compounds, I can't even tell you what they were. I know that in one case, I remember it was a test tube, and I put this final little thing in, I forget what it was, potassium something or other. And as soon as it touched the liquid, it just blew up. But it didn't blow up the test tube, because the test tube was open at the top. It went out of the top of the test tube and splat against the ceiling. Okay?
Wow.
And, oh yeah, it was like, it was like boom. I mean, a big boom. and went phoop, up to the ceiling where it splat. And it was like the Three Stooges with a cake that sticks to the ceiling, and they look up and it falls down in their face.
Totally.
Yeah, well, this was actually just stuck there, and it never came down. And then it solidified, and I got up there with a knife and pried it off the ceiling and threw it away quickly before anyone could see. And then when I looked up, I saw this really black spot that was expanding. Something was permeating. Yes, I don't know what it was.
So that process, whatever it was, wasn't over.
No, I figured, oh no, my whole room is gonna like disintegrate or something. I didn't know. So the next day, I find some ceiling paint downstairs, and I said, I'm gonna fix this. I don't want my parents to see. Now you gotta understand, I wasn't tall, but I stood in a chair I could not reach. So I took like my mother's broom and I duct taped, or black electrical taped a brush to the end of it. A brush, not a roller. If I was smart, I would have. I didn't know the difference.
Yeah.
And I stuck it in the paint and stuck it up in the ceiling, and then kind of brush. Hey, it looked pretty good. Totally missing the fact that white ceiling paint was dripping down into the carpet.
Oh boy.
Oh yeah. So, but hey, if my mother was gonna look down and not up, it was a win for me.
Yeah. Every little bit helps.
Yeah. So, yeah. So anyway, the bottom line is that after the ceiling paint dried, whatever that tenacious stuff was that I had created, it just gobbled up that ceiling paint and came back just as strong as ever. And when my dad came home, and of course I had tried to take the dried ceiling paint out of my carpet on the floor. It was a thick carpet, so I could kind of hide it a little.
Yeah.
So I managed to, hide that pretty much. He looked up at the ceiling and he goes, "What the hell's that?" And I'm like, I don't know, Dad. I think it's coming down from above. Yeah, I didn't want to get beat. So.
Oh my.
And he looked at the table and he saw the chemistry set and he said, "What did you do with the chemistry set?" I just mixed something. I didn't know what it was. It went poof and it went up to the ceiling and black. I don't know what happened. And he goes, "Well, you're lucky you didn't blow your head off." I said, "Why do they make these chemistry sets for kids?" Well, they usually follow directions. Yeah. Yeah, so anyway,
wow.
Yeah, he tried to paint it over, no go. So they had to totally sand down, refinish, and re-spackle the ceiling in order to get that thing to cover up finally. And I think it took about 2 years to actually not have a spot on the ceiling.
So what in the world did you create?
I have no idea, but it's still there to this day, I think.
Oh my God.
It's living in the ceiling. It's wondering, when am I going to come out,
Ooh,
when do I get out?
Zone. Right, exactly.
Yeah,
Tara D says, or poke your eye out. I was thinking about that. Yeah, exactly.
That's right.
Oh, and Mr. Dingo 57 says, awesome stream as always.
Oh, thanks, Mr. Dingo. I didn't even see you here. Thanks for coming. Yeah, no, I of course, I'm talking. Boy. Yeah. I'm just trying a 30-second shot here. I see some stars. I'm giving it a go.
Yeah, we're sort of outrunning the clouds or outweighting the clouds.
Yeah, I'm kind of just trying to see what'll happen, but it's getting worse, and I know that it's not going to get better. But I am just such a yearn for dark sky and stars, so I guess that makes me this way.
Yeah. W13 guy. No, W1.
Weird guy.
What is this guy? Oh yeah. But anyway, he says flubber.
Flubber, yeah, there you go.
Yeah, you made flubber.
Remember Son of Flubber?
Oh God, yes.
Oh yeah. Oh, I thought that was really cool. Yep. Let me see now if this is what I think it is. Let's zoom into this. Just trying to see something.
Kimmy, yes, it's addictive. You cannot leave. I got that. Uh-huh. Oh, thank you, Rockstar. Right back at ya.
Yeah, you are awesome, aren't you?
Oh, bless your heart.
Well, sure. You're awesome.
Well, I'm doing a deep curtsy. And then I'm trying to stand back up again. Well, that's okay. Here we go.
Yeah, well, I should show you on video. I can put your video out there. But, yeah, see, this cluster should show a lot more detail than this. I know it looks like we have stars, but you can see, you're just curious. It's out of curiosity to show you something here.
Yeah.
you'll notice that you see there's no stars in here very much, right? It's almost like you see a bunch of them, and then and then you see like a tongue of stars sticking up here. Well, actually, that's a dark nebula that's coming out here and covering the stars behind. See? So that's how that's working. Okay, in this particular case.
So even though it's a dark nebula, we don't see it that way.
No, our eye tends to think that it's a lack of something when in fact it's something obscuring something. It's obscuring what's behind. Yeah. Yeah. So I guess, yeah, and it's really blue because we're looking through light clouds, so we're not really seeing this as it should be. I mean, I recognize that we're not seeing very well here. There's nothing that we can do, unfortunately.
Kind of looks like Los Angeles skies.
Yeah, that's right. That's right. Los Angeles. Los Angeles.
Los Angeles.
Yes, Los Angeles. So let me try one last thing here for tonight, because we always do this if we can. Let me see if we can check this guy out, unless he's under clouds. Okay, first of all, we're going to go to a star. Let's see. All right, where are we going? We're going to Alzir. And we're going to then race down to this little nebula, Hubble's Variable Nebula. And let me see if we got, I don't know. I don't know. Don't know if the telescope is going to guide on it properly. I don't know. We'll see.
Suspense.
Yes. Yes. Suspense. That might be that right there. No, let's try it. Let's try it if we can do it. It's going to be there or it's not. And let's just make it a quick 15-second exposure at, let's see, 32,000? No, a little less than that. 20,000. Yeah, we'll try that. Let's see what we get. It should acquire. If it has acquired, we should be able to see Hubble's Variable Nebula.
Okay. Oh, thank you for all the kind words in chat, Kimmy and everybody. Thank you. It feels good.
Yeah, Carol's great. She does a really nice job.
Again, thank you.
I had invited Amanda to join us, but apparently she couldn't. Yeah, see? It's not there. I don't know. It should have been right there. So clearly there's an issue. Let me see if I can... Just a quick correction attempt here. I'm going to move us south a little bit. I want to see if it's south, and I can figure that out in just 10 seconds. We don't need to do it for 15. And I don't care if the guider's on tap or not. I can get rid of that. All right.
Sergeant Quinn says there's something moving back and forth. What would that be?
Don't know. I just love starry skies. Look at that. This is beautiful. All right. I don't know what's moving back and forth, Sergeant Quinn. I did not see it. Now let's try something else now.
David Schmidt is twisting your arm behind your back to keep the stream going. And Sergeant Quinn says whatever was moving back and forth is gone now.
Oh, okay.
It was the mothership, Sergeant Quinn.
Yeah. Not likely. All right, let me see. Okay. Again, I don't care if it acquires. We're only doing a 10-second shot.
Sergeant Quinn said it was left, right. It was the left mid part of the screen. Whatever.
Well, it's on the stream, so it'll be recorded in the stream.
Yeah.
So we got to check it out. If you got an approximate time for that, Sergeant Quinn, let us know. We'll go check it out. All right, I'm actually going to tell it to go. Actually, I'm going to tell it to go to. Yeah, no, it's not going to. Somehow, I think I have to align it again, and I don't know why. There's no reason I have to align it again, but apparently I do. I don't know why. All right.
Interesting.
Yeah, little things happen sometimes. But you see, I gotta fix them from long distance. I don't want to go out there and do it. You know what I mean?
Yeah.
Just for something simple like that. Now that should be Alzir. And so it should be moving us to Alzir. And that.
David Schmidt says he loves starting his mornings with this stream. He takes it as a lucky omen for the day.
Oh, good.
That is cool.
Yeah. Okay, so, all right, clearly my alignment has gone off on this, and I do not understand why. So, let's see if the scope is there. At least I think the scope's there. I should be able to go up and see that star then. Let's find out if that's where it is. Whoops, went the wrong way, sorry. I knew that too. Duh. I said, look, it's going the wrong way, and I know it is. Yeah, okay, so. Alright, I'm going to be doing some work here before I close tonight. 10 seconds at 20,000 on this. Yeah. The star I was looking for is not there. Alright, well, there we go. That's telling me something is not right in there, and I'll have to go fix it.
Ouch.
Is what it is, right?
Right.
Yeah, so if I say this star, let's see where that star is. We should see that star. You can't miss Athena. I don't know if that's Athena. Yeah.
Earth calling Athena. Athena, come in, please.
Yeah, so we're I'm still trying to figure this out. So it's there, so I want to see if we can. Okay, so if it's Athena, then it doesn't seem like it's bright enough. Yeah, see, that's not. It does not support this. That's not correct. Well, Unless... Yeah, see, that would have to be a red star right there. And not a red star, but a reddish star. Okay. Alright, well, I'm going to go and do some work in the observatory then before I sign off. Well, I have to sign off. But anyway, guys, thank you for coming. I will be doing some work in there now to just realign. I don't know why it went out of alignment, but it did. Of course, it has been very cold here, and it could have loosened up things based on the fact that the temperature has been in single digits overnight. So,
ouch again.
Yeah, I know. But, all right, well, hey, thank you guys. I was going to sign off an hour ago, if you remember.
See, you do that. That is your absolute habit.
Definitely my habit. Yeah, it is.
That's right.
So, but I will do that. Let me see if I can. No, I won't be able to. I'm trying to line up on one particular star, and I won't be able to do it. However, if I can get a hold of Sirius, then maybe Sirius should be. You can't miss it. It fills the whole. It fills the view. You not fill the view, but it really is obvious.
It's a big dog.
It is. All right. So clearly, I don't see it. Oh, maybe it's actually still. No. It should have been in there. Should have been in there. Oh, okay. Oh, see.
Oh, hello.
Yeah, that. That's very disconcerting. The fact that it's working. Because now that tells me, well, if it races somewhere else, but it's now put Sirius in the center. Now, if it goes somewhere else, then I'll know that there's an additional problem. Again, it could actually just be the guider. See, for the guider for Sirius, it's clear. It can see where it's trying to find. So it found Sirius. Yeah, let me show you what Sirius looks like at a 15-second exposure at 10,000.
Oh, cool.
Yeah, so we'll let it acquire. Sergeant Quinn, I don't really have an opinion on that camera. I've been looking at some of the ZWO cameras because I'm gonna actually probably buy one to make an all-sky camera. There's that's what Sirius looks like.
Wow.
Yeah, it's really bright. So, and if you think about it, the actual size of Sirius in the sky is incredibly smaller than that dot right there. Much smaller. It's just it's so bright that it makes the sensor bloat on a computer sensor like this. The camera sensor.
I see.
Mm-hmm. Yeah, but they're only ever just points of light. And the atmosphere makes their images look bigger too, of course. But incredible. But that's how Sirius looks. And these are just reflection artifacts. It's always good to take long exposure with your telescope so you can actually see what it's doing and where all the secondary reflections are coming from. And we're seeing those anyway right there.
Astonishing.
Well, pains in the butt.
Yeah, well, that too.
Yeah, especially since this thing is working, and now it's working, and it wasn't before. I don't get it. I still think it was that. I still think it was a problem with the with that darn guider. Okay, now it's going to go to Sirius before going up. Okay, it's going to go over to this object here. See, now we're doing testing, guys. Now we're actually doing troubleshooting.
This is a great insider look.
Yep. All right, now here comes Sirius. And then we're going to race up to this object here if we can actually get to it. So Sirius gets centered and then it goes away.
Huh.
And now it knows exactly where it should be going. So it should not get lost, and it should be right here. You know?
Huh.
So we're going to see. We shall see. Okay. We're also shooting through some light clouds. I know we are, so that's problematic. But let's try this. Let's just see if we can grab a little something here. 25 seconds at 20,000, 25,600. Let's see if the object I seek is going to be in the view. Yeah, weird guy. We talked about the LIGO detector detecting something that's potentially in the vicinity of Betelgeuse in terms of gravity waves. One of the astrophysicists on the team actually got up and walked outside to see if it was still there. Well, see, that's working now. Okay, this object here is Thor's helmet. And I guess, again, if the auto guider is not able to see with both of its telescopes, we get mixed results. So I think what I'm going to do is once this telescope goes to Arizona, that problem will be gone because it'll be a roll-off roof. But the telescope that's going to go in this dome is probably going to be another one of these. Maybe one that's a little different in its design so that I can actually take advantage and try some new things. Okay, well, now that I know this is working, I'm going to actually do a shot. I'm going to do a 30 seconds for at 32,000. So 2 stops up. In photography, a stop is measured by one, click over or one higher notch in exposure time. Mm. It's a 1-to-1 relationship. You go up on one and up on the other, and that's 2 stops. If you go up on one and down on the other, you get the same exact picture. But you might just have more noise because if you go up in the sensitivity, the higher the sensitivity, the more noise is in the image. And I tend to get rid of noise. Yeah, see, now that doesn't make any sense to me. See that it's got that trailing. It doesn't make any sense to me. But that's okay, because that's why you take so many.
Yeah.
I'm actually, Sergeant Quinn, on the next camera we're gonna have 42 megapixels. This one has 12 megapixels, 12.5, something like that. And we're gonna get 42.
Yowie.
Yeah, the stars are running for me.
Yeah.
That's funny, huh? Well, let's see if this works any better. Yeah, see what I mean? I didn't change a darn thing. And it just happens to be the way it works sometimes. Yep. This line is an artifact, which annoys me. I don't know why it's there, but it shouldn't be. It's probably from the light of Sirius, though. You can imagine the big ring, going around Sirius. So this could be.
And that part of it, right? Okay.
Yeah. Yeah. So this is confusing. Why this is working, I don't know. I'm gonna have to, this all has to work as it should from thousands of miles away.
Yeah.
Yep, it has to. Let's let's try. Let's try this little tiny open cluster. Didn't I tell you it was going to go?
Mm-hmm.
Yeah, I mean, I think half our audience already went because they think I was leaving.
No. Hey, come on. They know you better than that by now. Says the dog star ran away. That's it.
Yeah. Oops. Yeah, no, I don't think it ran away.
David Schmidt says, wow, look at the blazing red one right at the grid line. Yeah, I see that.
Are we mean here?
Down farther.
Right here?
Yeah, right there. I think that's the one he means at the grid line. Yeah.
Yeah, that star is W Canis Majoris.
Mm-hmm.
It's a pulsating variable, actually.
Am I correct? Betelgeuse is a variable star?
You're right. It is correct.
Okay.
It is, in fact. Okay, well, this should be Avery's Island, this little cluster here. Let's take a look, shall we?
Oh, shall we?
Yes. Yes, we shall. I'll go down to 12.8. We don't need higher than that. And let's go to 25 seconds. Don't need higher than that. We should be acquired by now. I'm saying acquired. Yeah, see, now we should have a clear view from here. So this image should be good. Hey, Emil. I didn't see Emil Shane come, but how are you?
No, I think Emil just entered, perhaps. I missed it otherwise.
Oh, well, thank goodness you got here, man, because we're almost done.
Yeah. Oh, come on, you're never done.
I know, right? I always say, you know what? I think my record is I said we're gonna stop, and yeah, I got to do this again. That's beautiful, though.
Oh.
I didn't give enough time. I said I'm going to go to 30 seconds too. I said that every time I'm about to quit, I say, okay, I'm going to quit now, and next thing you know, an hour later goes by. Okay, I'm going to quit, and then an hour later, and I did that once for a stream I was going to do for like an hour and a half, and it ended up being 5.5 hours long.
Whoa, Nelly.
You know why? Because the next object that I took a picture of turned out to be so stunning I could not stop. I had to do more. And then I figured, and I thought, well, if this is coming out so good, then this other one's gonna come out good. And if that's coming out good, then this one will probably come out great. Yeah.
Yeah.
And see, now we see Avery's Island. And you can see it. It looks beautiful. It's a beautiful open cluster. And show it to you the way it ought to be seen.
Did you say Avery's Island?
Avery's Island, yep.
Oh.
Yeah, that's a cool little cluster. I'm really liking it. Let's go see now if we can bring this back. And
David Schmidt compares stargazing to potato chips. You know, you can't stop at one.
Yeah, that's right. They always say Lay's potato chips.
That's right.
Nobody can eat.
You can't eat just one. Yeah.
You can't eat just one.
No.
All right. Well, you know what we're gonna do? Let's go see that star, David, that you talked about. I guess we gotta call it the Star of David.
Oh. Love it.
Wait, is that the one he wanted to see? Oh.
Let's see. I can't scroll up.
Oh, it was this one down here, wasn't it?
Yes, at the grid. There we
one.
go. The bright one. Yeah. The grid line.
Okay. So that's where we're going to look. So what star are we actually doing our precision alignment on? It looks like Sirius again. It is. And then we'll be able to get over to We're going to line up, and once it's aligned, it's going to shoot off. There it goes.
Kapowie.
And we should see that star show up, and there it is.
Aha.
Yeah. Yep. And you like to see these red stars. What they are actually, in many cases, is a star called a carbon star. In a star's later life, what it can do is it can make a lot of carbon in its core, and then that carbon gets dredged up out into the outer atmosphere. And there's several what they call dredge ups that occur. And sometimes that carbon gets brought to the surface like this. And when it does, well, then the star's surface ends up being inordinately red. And that's what we're seeing here, possibly. So let's take a look at what that star actually looks like. And my kudos to David Schmidt for finding it, for noticing it. So why don't we check it out, right?
Oh, let's.
Yep, we're going to call it David's star.
That is so cool.
Yeah. All right, so here we go. We'll see how this looks. Oh, I don't know if I gave enough time to acquire. Uh-oh. We'll see. No big deal. Sometimes I like letting trails... Oh, there we go.
Oh, that's it.
There you go, David. And I want you to notice there's another one in the view as well. Do you see it? It is not this one.
Ah, smaller. But yeah.
Where is it? It is not this one.
It's not that one.
Nope.
Ah, scanning. Is it less red? Is it the one diagonally up from that David star?
It's not as bright. That's correct, but it's not these anywhere in here.
And it's not the one if you go up on if you start a David star and go on a diagonal, it's not the bright one up to the left.
Up this way?
Yeah, it's not that one. Whoa, you just passed it. But yeah.
That guy? Nope.
No. Little higher up from that guy. I'm just guessing, I think, at this point. Because the one I thought it would have been was the one you said first of all. It's not.
It's not that one.
Yeah, it's not that one.
Yeah, this is very red. It's actually this one over here.
Oh my gosh. Yeah, good spot. It's tiny, but it's definitely red.
Yeah, well, again, that's probably very likely a carbon star. This may be an M-type star. This might be an M star. This might be an M star. There's more of them than any other kind. Okay, this isn't probably a special stellar classification because it's a carbon star. So, but it's pretty cool, isn't it?
It is.
Yeah, let's see if we can enrich in the colors by... I love it. We're actually able to dodge these clouds because it's really nasty out there. We're gonna go down.
That's astonishing. What's your guess on how you're able to dodge the clouds?
I'm just lucky. I haven't.
Okay.
That's all it is. Okay. We're gonna do 20 seconds at 6400 and see if we can actually get this star's red color really enriched. Okay.
Perfect music again.
I know we're processing in our minds, you know.
I love it. Yeah.
Oh, look at that. So now I zoom in on that guy. Yes, it's such a beautiful star. Now I'm going to take us into the editor and let's get rid of the. That's
wow.
Betelgeuse. That was Betelgeuse from before.
Okay. Never mind.
Yeah,
okay.
Yeah.
Now
now we're going to take this red star. Okay. And we're going to, let me do this again. We'll take this red star, and now let's take the color and make it what it should be. So that's about the right color right now. Right about there. So there we go. That's what it really looks like in the sky. And notice the other red one over there. Look at that.
Yeah.
So see, when people say, stars don't have a whole lot of color, well, you can see that they do. This star here, okay, these two here, that one there, that little tiny one, that little tiny one. They're not small. That doesn't mean this star is smaller than that one. It means that it's not as bright. It could actually be, like this star here, this could be a supergiant, just very far away. Okay? Compared to this, which might be a midget, tiny little M star.
Closer.
Yeah, but much closer, yeah.
I see.
That's right. It was a good omen today, David Schmidt. You're absolutely right. Oh, it's beautiful. Look at the richness of this field, just in color and just in variation too, and variability. There's just so many stars. You see, there's like a void here. Mm-hmm. Well, there's dark nebula here. Okay, if we look at the chart, okay, we can see that where we are is near what's called the Seagull Nebula. All right, and you'll see there's actually dark nebula here. So we're looking right above it, and it's dark here. See? Mm-hmm. Okay. We also notice there's a little nebula right here with that other star we talked about, right? Okay. And here it is. You can see a little bit of a red nebula.
Yeah.
Yeah. And I'm not trying to get nebulae tonight with clouds. It never works. And we are looking through some light clouds, which is why some of these look the way they do. But I recognize it. You may not.
Well, that's why you're here to point it out.
That's right. And David, I want to tell you exactly the name of that star. It's W Canis Majoris. W, capital W, Canis Majoris, and that's abbreviated CMA. W Canis Majoris. Yes, sir.
Fantastic.
That's your star, David. Yep. Without a doubt.
That is too cool. I love it.
Oh, yeah. It's very cool.
Good night, Kimmy, and stay safe.
Exactly. Yes, sirree.
And you've made David Schmidt very happy.
No, it's great. I'm glad that he enjoys this. Yeah. Because his energy is contagious to the kids that he teaches too. So.
Totally.
It's very important. Very important.
Pass it on.
That's right.
CND boy is in the house
hey,
with a thumbs up.
CND boy, Canada boy. He's from Canada.
Canada. I was wondering if that was it. Okay.
I think that you're from Canada, right? I think you told me that before. All right, we're going to go up to this guy and see if we can see any of the Seagull Nebula tonight. But I doubt it because of the nature of the clouds. But we'll give it a shot. Why not? Goodbye, W Canis Majoris. And are we going to go back to Sirius? Yep. Sirius is the stop-off point for this particular star. For this particular area of the sky. And once Sirius gets centered, it knows exactly how far to go to get to anything else around here. Okay. And up we go. Yep. And now we should be able to okay, so one of these stars is going to be the one we want. So let's make sure that we have the right one. So it is there, and I'm going to actually, I'm going to leave it right here for now, and I'm going to go up to a much higher setting temporarily just to see. Didn't I say I had to go?
Right, about how long ago?
Yeah, we'll just do 25 seconds right now. Okay, this is supposed to be part of the Seagull Nebula. Let's see. Can we see it though, actually? Maybe. There's that's the pull handle at the top of the dome. I'm hoping that's not in the way. And I do not. I don't see it. I mean, it might actually be down here. Either way, I'm going to have to realign the scope. I'm not happy with where it's going, but then again, it is a much more tight field, so I can see that might be a problem. Okay, let me just yeah, okay. Yeah, we'll get very good photos of this. Okay, one last thing here. Let's go to the heart-shaped cluster, and then we'll call it a night.
Yeah, that's what you always say.
Yeah. And of course, we are going to Sirius as our first point. And it's being auto-centered, and then it's going to race up to the heart-shaped cluster. See, that's where it thinks the center is. So that means that this is where the object we are seeking should be located. You know?
A couple of faint little thingies there.
Oh yeah, there's a few stars there. Let me get rid of this and this. Okay, and now let me do this and take us. Okay. I can see it's trying to acquire. You see the little bouncies. Okay.
Yeah.
This might be the heart-shaped cluster. How do we know? We're gonna go check it out. And how we do that? We do it with just a 25-second exposure. Wait a couple more seconds for it to acquire. And we go. I didn't give it enough time, but that's okay. I want to see. Emergency battery pack.
Yeah, wow. Where are you, Daisy and Zoe? Wow. Storm, it sounds like, or something. And I guess Kimmy has decided to stay. Well, that makes a bunch of us.
That's very good. Thanks for sticking around, Kimmy. Look at that. There's the heart-shaped cluster.
Well, there we have it.
Yep. And as always, I point out that whenever we look in these fields, look for the red stars. Okay, there's a faint one right there. There's one right there. Right there. Okay. We got that one. We've got one right there. One right there. One right there. It goes on and on and on. Yes. We have an off field to the right. There we go. One there. Yeah.
Yeah, Kimmy, it is a killer stream. It is. Oh, baby. What an amazing. Yeah, and the heart, am I correct? The heart actually has almost a Valentine heart shape there up at the top.
Yeah.
Do you think it's shaped, would you call it shaped more like the actual human heart or a Valentine heart?
Well, when they say heart shape, they don't ever think human heart shape. You know, it's always, you know, it's always that other thing, you know, the other, hold on one second. No, this is the board. Okay. I had to close down a screen. All right. So now, yeah, that's beautiful. So it looks good. So now I'm gonna take us back to this guy. The nice thing is these are all these are captured for good in the stream. So we have them.
Exactly right, for posterity.
We have them. Yep. And there's one that I'm hoping to catch for you guys before we go. Is it this one? That's the skull and crossbones. Yeah, let's do that.
Yo ho ho, matey.
Yo ho ho, and a bottle of rum.
Ah.
Okay, we're focusing on this. This star here. And then right from there, we're actually going to go just a little bit south. If we can. Yeah, it'll be close. And then we just drift down a little bit. Aye, this is the Skull and Crossbones Nebula. That's the Skull and Crossbones. Yeah. So let's actually take a picture of it first to make sure it's actually the Skull and Crossbones. You know, hard to see these through clouds anyway, but you know what? We'll give it a shot.
Why not?
Exactly.
Someplace there must be a list of who named all of these. Yes? Like who gave it that nomenclature? Pirates, whatever.
Oh, look at that star right there.
Oh.
Looks red. Wondering if that's looking odd to me. Yeah, let's see what we got there.
Wouldn't it be cool to capture some anomalous thing? Even if it isn't Betelgeuse.
Yeah.
Oh.
Okay, so let's go see it. Come on. Yeah, there it is. So it's a red star there. Well, that's pretty cool. Now, this is the Skull and Crossbones, and you're going to ask me, where's the skull, where's the crossbones?
Yeah.
I don't know.
Okay.
Yeah, I don't know. Let me take us up. Let's take this up to a little. Let's go to 20,000 for 30 seconds. All right. Yeah.
Buckle up and hold on to your hats.
Right. Stow the peg leg, sweetie, and just get on downstairs into the hold.
Oh no! Please!
Alright, so we should see now. It'll be a little brighter. Yeah, but you can see. Oh, we got a little bit of drift in there too. I don't like that. See that you can see the nebula though.
Yeah.
Yeah. So I have to figure out a way to make this look a little better. Let me just do one more shot. Just to make sure that it acquired. It probably didn't. It might not have acquired. I should probably check the optics too. I never thought about checking the optics of the auto guider.
Oh.
That could cause problems too. Yeah, definitely could cause problems. So, so we are looking at that little guy, but actually I'm going to move up in a bit because I'm going to show you something else that I think is really cool.
We are all eyes.
You are?
Well, yeah. Well, that's hey, I found an old science fiction movie called The Attack of the Eye Creatures. Yeah, I can.
Oh, was that the disembodied eyes that are just like,
no, actually,
crawling along the ground?
No, this was 1957, and it was so bad. But it did have the meme of the United States government covering up a UFO landing, which I thought was pretty cool.
That is cool.
Well, these were creatures that was sort of so low budget. I wondered, how did they get 6 of these suits, right?
Yeah.
Kind of had like lumpy eyes all over them. You don't want to know.
Oh, was it really that bad?
It was that bad.
Oh, man.
Yes, I watched the whole movie. Okay, but now I'm very curious because I've stumbled on the fact that way back in the early 50s there were sci-fi films in which the 50s in which the government was the bad guy and covering up stuff about UFOs. I don't know.
Wow.
Yeah.
Okay, I'm gonna find out why. I take this one more picture. If it doesn't work, it doesn't work. I still have to figure out why it's doing what it's doing.
Mm.
Yeah. And then I will move on. I got one last thing I want to show you. Yeah.
That's what you always say.
I know.
But wait, there's more.
Yeah, see, it's getting better. I don't know why it does this.
Interesting.
Yeah, but see, it's actually, this is the Skull and Crossbones Nebula. And it actually is bigger. Actually, it goes up to here. And when you see it like this, you can actually tell it's actually not that bad. You can actually see that its extent is pretty big. With the brightest part being down here, yeah. Again, stellar nurseries where stars are being born. And
I'm
it's
picturing
amazing.
the cradles.
Yeah.
Oh,
yeah, right. It's like, meh. Oh,
Right.
calm your UV. We'll be all right in a minute. Just sit there. Turn on the infrared, Frankie. You got to stay warm.
That's right. Oh, diaper change. Well.
Yeah. Yeah, so that's not bad. That actually looks okay. And then, okay, yes, I want to just take one more. I think that there's usually an issue. There's something called periodic error, and I have not trained the scope for periodic error yet.
But what does that really mean?
It means that every so often there's a worm gear which travels very slowly inside, and as perfect as it can be, it's not perfect. And so it takes about 6.4 minutes for one revolution of that gear. And in that time, you will cross a certain location, a certain point where the ability for the gear to hold on and keep everything lined up properly might fail. As you can see, we're past that now, and we're getting good shots now. Mm-hmm. Okay? So if you train for the periodic error correction, then the guider will know that, and it will know when to expect it, and it can correct for it. So I haven't done that yet, so that's why we're getting the occasional shots that don't look all that good.
Uh-huh.
Okay, and these still have a little bit of motion in them that I don't like. Okay, but that's all right. So anyway, what I'm going to do now is go back, because there is one thing that I think you guys really like. And it's this next little nebula here that I want to check out with you. It's not even a nebula per se. It is, but it's not. How's that for an explanation?
Well, it's a little confusing.
Yes. It's confusing, yes. I get it.
Well, I'm glad you do.
Yeah. This is called the Calabash Nebula, also known as the Rotten Egg Nebula. Hey.
That's weird.
Yeah, go figure.
Does it have something to do with sulfur?
No.
Nope.
All right. But we are lining up here on this star again. And then we'll zip on up to the Calabash Nebula.
I wondered, when you talked about several live streams ago, it was calabash, and what does that even mean? Well, apparently it is I don't know if it's deciduous or non-deciduous tree, but it is a tree. and it grows in California, I guess. But I wondered, is that there are a lot of there's a lot of astronomical stuff that is Shakespearean based, right? So I wondered if that was Calabash, Calibash, but it is spelled Cala.
Yeah.
That would be the tree, not the Shakespearean character. Never mind.
Okay, well, no, that's okay. I mean, and many of the stars have Arabic names too, so that's also something to consider. I'm going to do a shorter exposure here, 20 seconds here, just to identify, make sure we've got it. We might see we might see the another cluster on the right side. Let's find out. Oh yeah, there we are. Look at that.
Yeah. Absolutely.
Okay, so here's what I'm going to do. I'm going to center that up. As you can see, there it is. Can you see it?
I can't see it.
I can't either.
But we know it's there.
Yes, but I will, in fact, center it right up. But not by going that way. I got to go the other way. Just a minute. And then I'll bring it up a little. Too much. Okay. Okay. All right. So now what I have to do is, at this point, on the back of the auto guiding system, it's a blinking red light, guaranteed. And it takes about 15 to 20 seconds to acquire. And then it'll go solid. What it's doing is it's searching for a star to guide on. So I'm assuming that by now it has it. So we'll do 25 seconds at 20,000 here. And we will check out this beautiful remnant of a dying star. And you'll see that it's associated with a cluster of other stars as well. And this presents a bit of a problem, a quandary for astronomers. At least it did. It doesn't any longer, and I can explain why. But here is this nebula, and you'll see this beautiful nebula. In fact, if we close in on it a little bit, you see that
oh my God,
it actually has a little bit of a reddish ring around it. Okay, this star in the center is a white dwarf. It's a star that has died, and it indicates that this star had already reached the end of its lifetime. However, it's in a cluster of very young stars. So once again, how can that be? You know? How could it be that an old dying star is mixed in with a cluster of younger stars? And the answer is going back to what we talked about 1 hour 49 minutes ago, and that it's a line of sight illusion. This star is about 2,000 light years away. This cluster is over 4,000 light years away. So you'll pass this dying star, which is along the line of sight, long before you actually get to this cluster. You know, and Daniel Whitaker says oxygen 3. Excellent. You're absolutely right. What we see here is the expelled nebula, which is basically a nebula that is from the star's outer envelope that has been shed from the star. And we're seeing the oxygen that was in the atmosphere of that star. And no, it's not oxygen to help fires burn or anything like that, because you don't need oxygen for the stars to work. They use fusion, and nuclear fusion can happen two different ways in a star. One is with the proton-proton chain, it's called, and that's where you have two hydrogens that combine and form a deuterium atom, and then another hydrogen atom joins those and fuses, and you eventually get helium as a result, helium 3. And then That's one way. So that's fusing hydrogen into helium. Then you have something called the CNO cycle, and that's carbon, nitrogen, oxygen. And that's called a catalytic reaction, and those are where the stars are usually much more high in mass to actually have nitrogen and oxygen in their atmospheres that they might have made, because we're talking about in the core. And these then will create a cascading event where fusion products lead to, again, helium. So that's the CNO cycle. And those are the only two ways that fusion works that we know. So when we look at stuff like this, and as Daniel Whitaker pointed out by saying oxygen 3 here, absolutely. But if I can take a slightly deeper shot, maybe I've got to drop it a little bit. Let me go down to 12.8 and do 25 seconds. I want to kind of accentuate the colors that we're seeing in this object, because you see the blue, as Daniel says, you see that blue, which is oxygen 3, just like he said, doubly ionized oxygen. But you also see a little ring around the outside, a bit of a reddish tinge, and let's see if it shows up from the shot.
Yeah, that ring. It's interesting. Tara D says it looks like a dandelion, and Kimmy agrees. Yeah, like a dandelion.
Yeah.
When they go to that point where you can blow them and make a wish.
Yes,
yeah.
That's right. I had to do another one because we're at the periodic error location in the worm drive, so this one might also be a problem, but then the next one after it will be fine.
Meanwhile, David Schmidt wants to know if any newly formed stars have been discovered. He gives us an example, like one night it's not there and the next night it is, meaning that it formed years ago, and the light is just reaching us.
Yes, as a matter of fact, there are, and some of them are actually in the Orion Nebula, David. We don't see them. They're actually buried inside dust clouds, and we catch them through the infrared energy that we can trap in the telescopes. We see infrared light. So yeah, that's amazing. Okay, here is an example. Let's do this. Here's an example now. This nebula, again, it's probably not working like that, but you'll see the outer edge. See the outer red?
Yeah.
Yeah, and you see the green in there, and then you see a gap, and you see the white dwarf in there. Right. This is a shell. A spherical shell that's being given off from the star. And you might not think it's a spherical shell. It looks kind of like a ring. And we know we have the Ring Nebula in summer, so what's that, right? Well, it turns out most likely what we're seeing here is a spherical shell. And on the edges, where you're looking through more of the shell, front to back, it looks thicker. And facing you, you're looking through the least amount. That's facing you on this side.
Oh, I see.
So it ends up looking like a ring like this, no matter where you see it from in space. It'll always look like a ring. And that's possibly what we're seeing here. See? And again, this cluster is, it is a location where the planetary nebula, that is this object here, is 2,000 light years away, and the cluster is another 2,000 beyond that. So it's a line of sight illusion, So I hope you guys enjoy that, because I sure did, So
totally. And Kimmy also says, "Wish upon a dandelion and wish upon a star."
That's right.
That's so perfect.
It's like, when you wish upon a star.
There we go.
Yes. Well, I gotta thank you guys for coming. I have to go out there and put little Telly away, and then we shall actually convene again on the next clear night. Which, let me see if I can make a prediction here for you. Let's see.
And also, remember, on a clear night, you can see forever.
Exactly right. Oh, this is funny. I told you about Doug Trumbull earlier.
Yes.
I look at my text. He sent me a message already. Sent me a message with video. He did something really cool.
Oh, I love it.
Yeah. So I'll have to check that out later. Let's see now. Let's go to my weather here and see what we got. And we take a ride to the Magic Kingdom.
Ooh,
that's what
I'm
it
up
sounds
for that.
like.
Yeah.
That's what it sounds like. That's today. Today is today Wednesday.
Yes, it's Wednesday, the 22nd.
Okay, so Thursday. Oh yeah, Thursday's gonna be cloudy. When's the next clear night? No, we got snow. Jeez. Way too much snow, man.
Doggone it.
Oh yeah, we're gonna have snow for the next week and a half. Wow, well this is the last stream for a while, I guess, huh?
Oh, bummer.
So, well, then hold on, I'm not gonna tolerate that. Let's see here. I'm not gonna tolerate that.
Yeah, like my other colleague in Connecticut calls the weather services the weather terrorists.
The weather terrorists, yeah, that's funny. All right, so let's see.
Oh, Rascally Rabbit coming in for the end.
Hey, Rascally Rabbit.
Thanks.
Nice to see you. Yeah, Tara, see what she said? Read what Tara said.
I missed it.
That's right there. It's just a couple comments up.
Thanks again, Mark.
No.
That one?
No, it's right near the bottom.
Near the bottom?
Yeah, just like 5 up. 5 up from the bottom. 6 up from the bottom.
Crazy. I'm counting. I'm not seeing it. 1, 2, 3, 4, 5.
Tara D. She says, enjoy your last snowy winter.
Oh, I missed it. Ah, okay. Yeah, your last snow, right?
Yeah.
Yeah. Oh my God, that's going to be so incredible for you. Oh, and for us.
Yeah, I can't stand it. I can't stand winter. I hurt in the winter. That's the problem. I'm in pain in the winter, and I don't like it. Who does?
No, pain is not a good thing.
Yeah. Who likes pain in the winter? It's like, hey.
No.
All right, let me see something here.
People who go ice fishing, they like pain in the winter, I guess. I don't know.
Yeah. I'm not one of those. I mean, I used to like winter more than I do.
It sure gets in your way.
Well, more than I do now, anyway.
Yeah.
Excuse me. So where are we going here?
Daniel Whitaker, who lived in Arizona. There is some snow there sometimes.
Yeah. Flag. Yeah, if you go up to Flag.
Sure, right.
Yeah. Flag can be pretty chilly. But I don't mind it.
Yeah, it's big difference. A light snowfall that goes away in a couple of days, compared to what you guys have to face all the time, every winter.
Well, every winter, yeah.
Yeah.
Okay, so what star are we lining up? Oh, okay, Procyon. Haha. And then we're going to go to we're going to try to see the Butterfly Nebula if we can.
Ooh.
Don't expect to see butterflies.
No.
Oh my, butterflies! No.
No, not exactly.
Yeah. Well, hey, we're having fun, right?
Right. And learning. See, this is the thing. It's like, wow. I mean, the absorption of information presented with, given the way you give it. Words fail me.
That's okay, as long as Telescope doesn't fail me.
And that's the point.
And that's the truth. All right, so let's do in this next encore object. I should be calling these encores because
I like that.
It just doesn't end.
Well, sure. It's like, the audience applauds, and out comes the conductor for like yet another, right? And over. Yeah, well, so that's it. We're applauding you, and
when you go see a live show like that, how many times do they play an encore? Sometimes more than once.
Oh yeah.
So I'm doing a repeat. These are encores. These are encore objects for you because you guys are attentive and incredibly awesome.
Yeah. Well, hey, you inspire that awesomeness. So.
Well, I think that it's probably a bit mutual,
Mm-hmm. Yeah.
I know this is a smaller object. I'm trying to see if I caught it here. It's very small. Where is it? I've seen it before. This isn't it, is it? No.
Meanwhile, as you're looking, I will tell you that D. Smith says, Mark, this makes me really appreciate that you used to manually do this for us before you had the dome. Freezing, but still sharing with us.
Yeah, but I could never do it this long.
Yeah, right.
That's the problem. I couldn't do it this long because it was just... I literally... I'd be out there like this. Oh, okay. I'd be so cold. Yep, I would.
Yep. Teeth chatteringly cold.
Mm-hmm. That is right. Okay, I don't see it there, so I might have the wrong... I have to look that one up and figure out the exposures that are better, because it is a... Oh, it's faint. That's a really faint guy. I didn't realize how faint it was. Yeah. It's over 1,000 light years away, isn't it?
Wow.
I think so. Yeah, it's 4,400 light years away.
Give or take.
Yeah. 4465 if you want to be relatively unsure. Yeah. Okay. I've seen it before, but I think maybe I didn't see it in exactly the way I thought I saw it. I'm trying to remember if I saw it here or in another telescope. It could have been another telescope. It could have been. Yeah. Okay, this one we gotta see. This one we have to see. Let's go take a look at what the telescope's doing. Well, if I could, how about that? My telescope application crashed. How about that? Not the telescope, the camera.
Ah.
Yeah, that's pointing up. I'm not sure that the guider is going to work on that. Well, maybe because we'll see. We'll see. We will see. All right. Let's let it acquire if it can. Actually, let me go do a 4K shot here. See if it's there.
Yeah, Kimmy, so true. When you're having fun, time flies.
Well, I don't see it in here, but maybe it's there and I don't recognize it yet. Alright, so we're gonna cut this off. We'll just try 25 seconds at 20,000. I'm trying to find a little planetary nebula that's here that I saw the other night. It's beautiful. It It'd be a great object to end on.
Oh, let's find it.
I know. It just becomes so funny, isn't it?
Yeah, really.
Yeah. But it's... You see, I don't get it. See, it's like some are right in the middle and some just don't show up. I don't get it.
Interesting. And if you don't get it,
yeah,
wow.
It should be here. You know, so I don't get why it's not here. I don't understand that. Intermittent operation is not acceptable. That is not acceptable behavior.
Strike it down.
Yeah. But if I want to look at that star, I can probably go to that star. Let's see here.
Daniel Whitaker asks, is it quadrant dependent or anything else like that? Pattern failure?
No, it's actually it has to do, I think, with the fact that it couldn't acquire the star it was trying to get to. I'm sorry, the object, because it was trying to acquire a star ahead of time to then leapfrog to this object, but it couldn't do it because the dome, once again, is blocking. If you look here, you can see the telescope barrel. Again, the guider is on the other side of this, and it's going to be partially obscured by the dome, so it certainly can't find. Here it can't even find a star. It should be a very relatively easy thing to do. It shouldn't even be a thought process. So it can't find it because of the fact that it can't guide. It can't auto guide on it. So I guess what I'm going to have to do now, but if I go farther south where the guider is out in the open and not subject to the dome garbage, it'll be fine. I'm actually trying to think of ways to get rid of the top of the dome and just have something else that's more wide open for here. But we had 60-mile-an-hour winds come through here at one point, and this dome weathered very well with the new design. Because see, these parts here in the dome, these things here, these are shutters that close. This is the opening right here, and these shutters will close that opening. Right, they're nested in each other. One comes over and then goes down to there. Well, I've had 3 sets of those shutters get ripped off in storms and fly across the yard.
Oh, whoa.
Yeah, and 3 times the folks from Next Dome, the people that make the dome, sent me replacement shutters for absolutely nothing.
Wow.
They stand behind their product, and then they invented a way that I was helping them figure out a way to hold these shutters down. And they figured out a way, and they weathered 60-mile-an-hour winds when it only said they could handle 50-mile-an-hour winds and no more. Well, it handled 60-mile-an-hour winds.
Outstanding.
Yeah, it was. However, in the winter, ice gets caught under these hold-downs, and it binds these shutters. So it's just, this is not a winter. This is not a winter-type installation. You can't use this for the winter. It needs to be a roll-off roof. Wherever you go, roll-off roof is the only way. Because that way it'll allow you, it gives you more room. Because you'll be nuts if you try to find some place to go stand in a corner inside one of these. Yeah, that's a little joke.
Yeah, just a little joke.
Yeah, but anyway, okay. This is okay. Now, really, I'm gonna have to go now. Here, we're gonna have to shut down. But I want to thank you guys for coming out. This is really the end for tonight. I'm not going to go to any more objects.
No more encores.
Yeah, no more encores because the encore didn't work that time. Because this freaking auto guider did not want to find that which I was seeking.
Well.
I will be going out to close up the dome. So, guys, I want to thank you for coming out, and have a good night. And I will be here with you the next clear night because I can't get enough and I don't know when to quit. And I think you realize that. You guys are great. Hey, you guys have a good evening. And from Carol, Carl, and I, Carl behind the Obsidian Curtain on KGRAradio.com, KGRAradio.com, 7 p.m. on Friday nights. That's her show.
Thank you for that, Mark.
Of course. Our show is SkyTour Radio, which is on Amanda Curran and I. Amanda Curran and I join she's my co-host, and we have SkyTour Radio Sunday nights from 8 p.m. until 10 p.m. Eastern Time. And then don't forget SkyTour LiveStream on Facebook, and you will find a lot of the pictures I showed you tonight are there for your consumption. You can take them down and enjoy them. All right. So, as far as a link, that's a good call. I have to put a link in there, don't I?
Yeah, that's a good idea.
It would be a good idea if I could just, figure out a way to do that right away, and I think I have. So, excellent. I'm going to do that. So, yeah, SkyTour Livestream on Facebook. You just look up SkyTour, one word, Livestream, second word, on Facebook. And you'll see SkyTour Livestream with Mark D'Antonio, and that's where you go. And you can enjoy it. You can go and look at all the photos of all the things we've taken, which I think you will enjoy. And then you can also go to SkyTour Livestream, as you have here on YouTube, and subscribe. I think you should subscribe because then you get a lot of really cool free stuff too. We like to do. We offer up to you. Okay, so this is SkyTour Livestream right here. That's the link for SkyTour Livestream. You're here, so obviously you know that. And we also have the book, The Populated Universe, available at Amazon. It's really a big, beautiful, oversized book, 8x10, over 300 pages, lots of color photos, many of which I created a lot of the images myself, either from SkyTour Livestream or, in fact, via just creating renderings. I've been in the computer-generated world for almost 20 years. And I create photorealistic looking planets with surfaces and stars. And that really comes into play when you're trying to illustrate alien worlds. So you guys have a good night. And I will see you on the next go-round. And Carol, do you have any parting comments for our wonderful folks here?
I just want to say everybody here is absolutely fabulous. What you said earlier about,
aren't they?
The education level and the outreach, the kindness, the camaraderie. Thank you for all your kind words, everybody. I do appreciate it.
Yeah.
And thank you, Mark, for bringing me on board. I love it.
Oh, of course. You guys you're wonderful, Carol. And, the people that watch, they deserve you.
Oh, you're so sweet. Well, you just give such a gift to everybody. Stop me before I start gushing too much over what you do.
You're kind.
It's
kind.
fabulous. And,
you're very
thank
kind.
you.
Okay, well, you know what? I appreciate that. Thank you, Carol. If you guys are in Nevada, go to Laughlin in February from the 15th to the 23rd is the Mega UFO Con there at the Aquarius Resort. I'll be speaking there that week. And then I'll be in Arizona after that to pour the foundation for the new observatory. More excited than I can tell you. And then we'll have SkyTour Livestream West and East here. So, that said, you guys have a good evening, and I will get back to you on the flip-flop. Remember that?
On the flip-flop.
Yeah.
On the next clear night.
On the next clear night. Good night, everybody, and have a good evening.